And Lauri, you have the floor. I will just change the slides.
Thank you. Can you hear me?
Yes, very well.
Okay. Bonjour to Montreal. It's very kind that you have invited me here. Actually, I have been involved in many workshops in this series, and I was there when this was started more than 10 years ago. So it is very nice to return. So my topic today is why is it so difficult to comprehend lean for many people? And if you change the switch the slide, so we go forward. So is it sure that people do not comprehend lean? I think there are many indications for that. There are many people who just do not get lean. It is being presented, it is being demonstrated. They know something about that, and they have the power to implement lean in the company or project, but they are just not doing that. Another indication is that many people do not consider waste as an important or worthwhile phenomenon. And of course, we know that waste is the starting point of lean. And they may have unhelpful ideas on how to reduce or eliminate waste. Especially that decisions would suffice to do that. And now I realize the version is perhaps not the latest one, because there are some Finnish word which we can just neglect here. So the next slide, please. So my overall argument here is that lean is difficult to understand if one's mental model or models are not compatible with lean's basic assumptions and tenets. And this applies especially to waste. Please, the following slide. So, what are these mental models? This is not exactly new, but this idea of mental models has only slowly diffused in cognition science and psychology. And especially Professor Johnson Laird has been one of the champions of mental models. So the question is how people reason in the first place. And the most common understanding has been that people reason in the same way as they form sentences and speak them out. So this is called sentential or propositional reasoning. And when we are speaking, so we are more or less following laws of thought, formal logic, a bit of probability calculus, rational decision making, all in an intuitive way. This idea of mental models is that people create internal models of the external world and are using these models for drawing conclusions as support. However, and this is my own observation or hypothesis, mental models do not only support, but actually they restrict inferences, observations, and action. And please, the following slide. So the naive understanding, and I think I like this, and everybody likes this, is that we have direct access to the world through our observations and action, and then we are reasoning and creating sentences which might be internal, or we might externalize them. So the mental model idea is a bit different, and please switch the slide. Here the idea is that between the world and ourselves there is a mental model that is influencing what we observe, how we act, and which most importantly influences our reasoning. So the next slide. If we accept this idea of mental models, so there are next questions like, how do we get mental models? Perhaps the most common way is through our own cognitive capacity, because this is constantly occurring in our mind. We create mental models of the situations and use them for decision making or prediction and so on. However, mental models are diffused also by education, and of course they are diffused through discussions with others or by learning from others. And the next one. Next one. Sorry, this is a slide which I deleted. Yeah, okay, this one. So, which kind of mental models are problematic in this context, namely understanding of lean? I think there are at least 3 very common mental models which are not compatible with lean at all. First, that a decision leads to an outcome. Second, that production is a transformation of inputs to outputs. And third, that knowledge, say, for solutions or design, is acquired by deduction from ideas in our mind, or what generally is acknowledged as true, like scientific theories. So next I will go through these one by one. Decision leads to an outcome. And then the next one. Here the background is in economics. And now the economics we are learning in our introductory and further courses in the university is so-called neoclassical economics. Before that, there was something called political economy. That political economy was looking at production and distribution, and the main problem was which are the determinants of wealth. However, that paradigm of political economy ran into problems. One problem was that production was studied also by engineers, and there was no clear borderline between engineers and economists. when looking at production. Already in the 19th century, other ideas started to develop, and they were mature in the late 40s. Now the whole function of economics was changed to look at behavior under scarcity. And under scarcity, it's important to choose wisely. So the focus changed to decisions. And especially it was thought that decisions are optimal as decisions are made by economic actors. And that was very handy for the mathematization of economics. The earlier focus on production was just pushed away. Production was seen as just data, something given. And the next one. The ideas of neoclassical economics were attractive and successful. And here we can see how the idea of production being optimum replaced the idea that there would be waste in production from 30s onwards or so. And this is, of course, from Ngram service by Google, which is looking at the frequency of words or word strings in published literature. And the next one. This one, yes. So the mental model here, which is problematic, is that decisions lead to outcomes. And if we assume, like it is done in economics, that decisions are optimal, so we come to the conclusion that also outcomes will be optimal. And now all revolves around decisions, but sometimes it is realized that outcomes are not the best possible. Rather, there is waste. And a few years ago, there was a big international study by OECD on healthcare waste, and actually it is better than I'm stating here. In the summary, it presented that there are two principles to tackle waste. First, stop spending on things that do not improve health. And secondly, swap inputs and change approaches when less pricey alternatives are available. What we see here is that those two principles are about decisions. Do another kind of decision, have another decision rule. Then if we look at construction economics, so in the popular textbook, British textbook, Myers says that businesses will never waste inputs. A business will not use 10 units of capital if it can use only 8 units of capital. And in one sense, this is unbelievable when we know how much waste there is in construction. But to the benefit of Myers, maybe we must think that he thinks that businesses will never decide to waste inputs. So in that sense, in both cases, the question is about tackling waste through decisions. Will it be successful? No. It is wrong reasoning. So, and that reasoning is, first, we spot waste in the outcomes. Second, we start considering how to change the preceding decisions for eliminating that waste. Why this is wrong? Because a decision as such may lead to waste. However, more often waste is emerging during the implementation of that decision. And we need to understand what is causing waste for eliminating that cause. That means that we are not using deduction, but rather we are using regressive inferences, reasoning backwards when deduction is reasoning forwards. So the corrected understanding here is decision leads to implementation. The decision exists only in the Platonic world of ideas. Implementation happens in the material world. Only in that way gets a decision realized. And that implementation leads to outcomes. And actually, I like to note that implementation, creating of effects, the word production can be used for that too. So this neglect, sidelining of production is also here the basic problem. And I myself realized this only maybe 18 months ago, when one sees economists to speak or write about decisions, they never say that actually it is only the Platonic decision. They are not meaning that they are not covering implementation. And to me, it is a big problem, big blind conceptual spot. The other second mental model is that production is a transformation of inputs to outputs. And if you have read any of my writings, so you know that this is something I encountered already 20 years ago, but let's go forward. Here the background is also in economics, and especially what is called production function, presented by the British economist Philip Wicksteed in 1894. Relationship between output and inputs of production. P being output, X1, X2, and so on being inputs. And actually, this has been a very bad idea. And it was poorly presented because Wicksteed did not explain what X1 and X2 and so on, what they stand for or what P stands for. Just a formula, but so we humans are such that a formula seems elegant and interesting, and there has been much work to kind of fill in contents into this a bit chaotic formula. Also, the problem is that this is looking at production from outside. Production is a black box. we cannot see what is happening there in production. We just see the inputs, we just see the outputs. Of course, productivity has been defined in this black box way, and there's much ado in economics around these ideas. So what is the problem? Can we look at the black box still with? But we can have, yeah. So the problem here is that waste is not here anywhere. We are not thinking how much factors of production or inputs we are wasting when we are looking at production, or we are not looking what is the share of wasted output. So again, there's a conceptual blind spot regarding waste. Next one. This idea is so general and high level that, of course, we are wondering how it can be practically used, but the way to use it is through decomposition, that is breaking down the big production task into smaller ones and thinking that all the smaller ones are similar black boxes, and also thinking that they are mutually independent, which is very handy because we can then manage and treat every box separately and think that the sum represent the optimum if we are optimizing all the small boxes. And the next one. So this is what I have called transformation view of production, which has been used and still being used, and which as such has been detrimental because it is creating waste. Next one. So as I said, so waste is not visible, time is not missing, even if time is an input to production. And next one. I'm not going into detail, but there's a corrective which we know, namely the flow idea of production. We are looking at what is happening in production in time. The third mental model here is about epistemology, the idea that knowledge can be required only by deduction from ideas in our mind towards the world. And the next one. There may be several sources to it, but especially in construction, one very influential source has been in scientific engineering, which was first voiced in a systematic manner by the Scott Rankin in 1858. And next one. And the idea there is to use physical theories for engineering. Before that, engineering and physics were considered as separate. And we again encounter the idea of optimality. We encounter the idea that a physical theory is so powerful that it contrasts with practical knowledge. The main thing is to get the design correct from a physical viewpoint, and then it is just for other people with less capabilities to realize that. Next one. And actually, this is Plato's view on science. Knowledge is acquired by deduction from the ideas in our mind to the world. Next one. Engineering science has been very close to Platonic ideas, pursuit of optimum, neglect of practical implementation, and focus on deduction. And next one. And the problem is here twofold. It is seen that optimum as such eliminates waste. There's no waste if we have the optimum design. And of course, we see that its optimum is not always realized, but then investigation of waste requires a very different approach, induction and abduction, recursive inferences, starting from phenomena to understand what went wrong. Next one. And actually here we are on Aristotle's view on science. It is a two-way traffic from the world to our ideas. And next one. And the corrective here, which we know, is of course very practical. Plan, do, check, act. Plan, do is deduction, and check, act is the other way around. So this, which seems very simple, actually is realizing the fine Aristotelian vision of science. And next one, towards conclusions. And next one. So if waste is not in our vocabulary and mind, because our mental models are not pushing it to be there. So chances are that we are letting high levels of waste to exist because we do not see it. So it is accepted waste. We may be actively increasing waste because we do not understand its causes and we do not see it. Created waste. An example in construction is the use of CPM. And even if we happen to spot waste, so we fail to eliminate because we do not understand the mechanism through which it is originated. Helplessness in front of waste. So these are the problems created by mental models. In the last slide, I'm presenting a few of my own papers in which some aspects presented here have been analyzed further. Thank you very much for your attention, and I am very keen to have your feedback.
Thank you very much, Lauri. You didn't hear the applause, but everybody was clapping. Thanks a lot for this very thought-provoking lecture. And I should say that I was really expecting something like that from you. Let's see if there are questions. We have several minutes, 5 minutes for questions from the public. Yeah, I can see a question from my colleague Erik Poirier.
Farook has, maybe you can take Farook.
Ah, okay. And Farook Hamzeh has a question.
And I have a question also. I'll let Farook.
Farook, would you like to ask your question?
Yes, sure. Thank you, Dr. Koskela, for the beautiful thought-provoking presentation. My comment and follow-up question is related to this balance between the Plato's theories and Aristotle, which I want to say I was really impressed. That paper that you published in Journal of Construction Engineering and Management, for me, it was the most thought-provoking paper that I felt that came out of all our community, that paper. And the beauty of it is how you're able to understand the balance between the theory of forms, which are the origins, and these are forms that have to manifest in the real world, and they cannot manifest without a manifestation mechanism. And this mechanism was given to us by Aristotle. And in that paper, we were able to match these two, while those were kind of the outcome of a struggle between philosophers and thinkers for centuries. And I was very positively surprised with the outcome of that journal. I just want to say that sometimes that the idea of Plato's ideas of forms is sometimes misunderstood because they are taking it on its own without its complementary part from Aristotle. And his idea is that the initial forms or archetypes, they have to translate into reality through a mechanism. And that mechanism was kind of not very well understood. Plotinus tried to explain that with the theory of emanation, and so many other philosophers tried to explain that. But until also Aristotle came and brought the other part of how that forms or that how archetypes have to translate into reality through a mechanism, until those were balanced. And with your paper, you thought that you presented that very clearly. Any comments you have on this, what I mentioned? I'd like to hear your opinion on that, which was, I'll say, one of the most intellectually thought-provoking papers I've ever read. So thank you so much for that.
Oh, thank you. So actually, you have answered to yourself. So if I understand right, and the transmission is not the best possible, but quite sufficient. So you were speaking about the forms, a term used by Aristotle, and my view is that there might be still more at Aristotle, which could be used even now with benefit. So all PhD students, you should look at Aristotle a bit at least, and maybe there will be a big idea emerging somewhere. And I think I have read some papers which are cultivating the idea of those forms, but I have not used them myself.
Thank you very much. Another question by Erik. Maybe this will be the last one.
Okay, so well, maybe, okay, well then it's more of a point for discussion.
Now I cannot hear anything.
Okay, can you hear me now?
Yes.
Okay, so the approach is, Aristotle and Plato, so we're in the classical positioning, epistemic positioning. We're looking at new approaches, more modern approaches around, for instance, critical realism and its relationship to reality, and could these new modern approaches, and I'll point to critical realism as a way to perhaps stratify this notion of or our relationship to reality. The reason I'm saying this because it was interesting saying, critical realism stratifies reality into three layers: the real, I'm missing one, and then the empirical domain. So what we can measure, you can measure phenomena, but then that can explain sort of a real world phenomena on a broader scale. Could these new approaches help us better understand and position waste in this case, or new phenomena as they emerge? So
possibly it is a research task. My concern has been that old and powerful ideas have been forgotten. They are not used, even if they could very well be used. So starting from the basics, and what you are alluding is that one could then have a more sophisticated view by introducing new ideas like critical realism. I agree on that. But also I could mention that I am not happy with how philosophy is being taught in the schools. Kind of philosophy 101 in schools or universities. The connections to current day ideas in management, science, and so on are not presented clearly, even if there are very heavy connections, and new understanding could be created by bringing Plato and Aristotle on board.
Okay, thank you very much. This is all the time that we had for questions after the first keynote. It's really a wonderful beginning to these 2 days of discussions. A very scientific, a very philosophical approach, which brings us back to like the basics of our life, of our existence, of science, of what do we see and what we do, how do you think about everything, and yeah, it's wonderful. Thank you very much, Dr. Koskela. And,
thank you very much.
If you can stay further on during our workshop, we'll be very, very happy, but I understand if you can not. Okay, thank you.
Thank you.
And now we have 3 presentations by from our research group, actually, beginning by Brenda da Silva, Laurindo, followed by Marie Reumont, Erik Poirier, and finalized by Mauricio Velasquez, whom I don't see where he is. Ah, he's here. Okay. Okay, Brenda, you have the floor. Erik, can you pull out the presentation, please? Okay. Okay.
Vous baissez ça? Hi everyone, I'm Brenda. I will be presenting my paper that I wrote with the supervision of Erik. I have to speak here? Okay. It's because I'm so small. So I will be presenting my paper that I wrote with the supervision of Danielle and Erik. And it's about how to improve value in integrated design methods. If I can go. Okay. So a little bit of research motivation. We researched in the literature, and we find out that there's a lot of difficulty in defining value. And that's due to its complexity, mainly its subjectivity in very complex projects, so big projects with a lot of stakeholders. Mainly, the program requirements are defined by the paying client. We'll talk a little bit more about that in the next slides. We need projects that are better fit for purposes and use. We deliver a lot of projects in construction right now that are not fit for its uses, and there is a lack of information concerning the user involvement and its benefits in projects. So the objective will be to investigate the user contribution to effective value setting. A little bit of the context. We know that to deliver better projects with the less cost impact, we should concentrate in the beginning, in the stages of the project. And so the project definition phase. But what happens is that in the design briefing process right now, we have a lot of discussion between paying clients and designers, and a gap of information about the users. So the users are not really that considered in the project. And also in the project management style that we have right now in the construction, we froze our goals in the beginning of the project. So we gather the needs, we decide the functional requirements, and we froze these requirements, and we get this to the end of the project, the same requirements for all the projects to the end. The problem is that these requirements, they change for all the projects. And if the project is a long-term project, it will change a lot. And so this adds a little bit more of complexity in defining the targets from the beginning of the project, because they will change, and it's normal. And if we don't consider the user in these types of projects, what we'll have is that possibly the project in the end that will be delivered, they will not be fit for the user needs because they were not updated or they were well collected in the beginning because we did not consider the user. So we will explore as a solution. The idea is that we will consider the user to define project purposes. And with this definition of purposes, we'll gather this information. And in the iterative definition cycle of the project, we will gather all the criteria, we'll test these criteria, and we will improve the design, the final concept, the final solution. And we'll gather also, and we use as well the target value delivery concept to help with some principles so we can drive value up while driving cost down, considering all the project constraints. And so when we drive value up by delivering a concept that will fulfill the initial purposes that consider the user, so will be fit for its use in the end. So just to summarize a little bit of the solution domain that we are exploring, we use the integrated design process that will be used to foster collaboration between a multidisciplinary team of stakeholders, and we will optimize resource use. We'll use the target value delivery as a way to improve project delivery, project value delivery, and to deliver a design that is better fit to its cost, that will have a better cost estimate. And we use the lean-led design, or a lean design method, to put the user in the process, to empower the user to participate in the process, and to improve the flow optimization. And here I have a little image of how each of these methods can fit in the whole process of the construction. And so the lean design is in the beginning of the process, it's more useful in the beginning of the process. And here I talk about the lean-led design. That's why in the beginning of the process. And the target value delivery, it can be used throughout the entire project. Okay, the research method that I will use is a constructive research method. So we were based in the beginning in the theory that's from Koskela. I lost my references here, but it's from Koskela, and that's the transformation flow value theory. And from its theory, what we have is that the requirement will be defined by the customer, and these requirements will be transformed in the supplier chain of value, and will be delivered as value. So, to deliver value to a project, we need to define great requirements. We need a good definition of requirements, and for us, it's with the user being involved in the process. And to test this theory, we will consider 2 case studies, and we made some workshop observations, analyzed some documents, and we conducted semi-structured interviews. So here I have images of both case studies and a little explanation of both of them, a little context. And here are the images that I'm showing you. This one is an integrated design process that was made for the first case study. And here we have the professionals discussing about the solution. And the second one is a lean design workshop that was made to simulate user flows in the environment for the second case study. I will present you a little comparison between both cases. Both were in education institutions, both were used the integrated design process, and had government representatives in the process. The difference between them is in the workshops. For the first case study, the users were participating in only in the lean workshops, and the professionals only in the integrated design process workshops. And for the second case, both of them were together in both types of workshops. So why I'm talking about that? Because when we look at the findings, we see that for the first solution, where the users were not included in the process together with the professionals, we have a lack of alignment with the needs by the users and the requirements defined in the program. So actually, if we deliver this solution at the end, the solution that were defined in the requirements program, we'll have a lack of space and too much space that were not used. So a waste of space and a lack of space in the same solution because we cannot deliver the right solution. And the lean-led design from the interviews, we find out that the lean-led design workshop provided better information for the delivery team about the user needs, and that's even with the user representatives in the process. So even the representatives of the users had the solution clearer in their minds because of the workshop. And the collaboration was higher when the project used the lean-led design workshop, and that we find out from both the observations of the workshops and the interviews as of notes that people made from the interviews. So in conclusion, there's a great possibility of value enhancement by combining integrated design process with a lean-led design. The lean-led design is a promising alternative for capturing user needs, even when those users cannot be present. And the deliberate use of TVD principles can increase project value delivery. As we saw, they did not use target value delivery in the process, but they already increased the delivery process, the value delivery process, the value delivery from the project. So if we use it in conscious mind, the solution will be capable to deliver better value. Future research, in-depth analysis of target value delivery and lean-led design in the integrated design process. That's what we are doing a little bit right now, and we suggest to continue an exploration of user involvement in other types of projects, as the user here was considered only in an educational institution, and exploration of other tools and methodologies to increase user involvement. Here we only explored the lean-led design. Here are my references. Thank you. And if you want to discuss a little bit about that, I have my contacts here.
Wonderful time management. Thank you very much. We have time for one quick question. Yeah. Is there a question online, maybe? Yeah, go ahead, Dominic.
Can you explain, in your view, the difference between, we use a lot of acronym in construction, and you seem to be sort of adding more, the difference between integrated design practice, so IDP and TVD, and what, so can you explain, in your view, the difference between IDP and TVD, and why was TVD not used in this project?
Okay. For me, the integrated design process I consider here is the one implemented here in Quebec. So in this process, they are not that focused on value. The idea is to, in the integrated design process, is that we will gather multiple stakeholders, we will participate in workshops together throughout the entire project, but the focus in value is not the present, it's more about resource optimization and cost optimization, and not in value. So if we look at the target value delivery concept that is more about target costing, that's from the first concept that appeared. Okay, it's close to it, but as I'm looking at the target value delivery, mainly in the value side, that's the difference for me. It's the value focus of target value delivery.
Thank you.
You're welcome.
Okay, parfait. Merci, Brenda. Question of language. Language is important. We learned that with Lauri. Okay, I'm going to go right into it where time is short. I'm going to present, share my screen, and of course, thank you to Ivanka and Clément for really having spearheaded this organization. I'm going to talk about BIM as an obligatory passage point with my colleague Marie, and I'm going to try to get Marie on the screen. I think one thing when we're looking at how social sciences can contribute to our field, the most important is the multidisciplinary nature, and we have to go and get that expertise. In construction management and engineering, we're not social scientists. So I was lucky enough to work with Marie, who's specialized in organizational communications, and also James Lapalme, who's in organizational psychology. Okay, here we go. You should see my screen. Unfortunately, we don't. I'm going to try to navigate Marie. Toi, tu nous entends bien, Marie? T'es là?
Absolument.
OK, super. Good. All right, we're going to... Oui, on t'entend très bien. OK, on va faire ça vite, masquer les commandes. OK. So, this is a project, a 2-year project that we undertook with a large public organization that will remain nameless. Okay, I think we don't have to position our work. Digital transformation is a key component of, key talking point, a lot of importance given to it to transform the way that we deliver, maintain, and use our built asset industry. It's a huge opportunity, but there's a lot of underlying things, and I've been exploring those underlying issues and mechanisms for a long time. This is where we're positioning this work. We're also looking in the civil domain and transport infrastructure domain, a domain that I mean, some will say BIM isn't as prevalent, and there's been a lot of growth in BIM in the transport and infrastructure domain. Although when you look at the domain itself, they've been using GIS, they've been using technologies for many decades. So this notion of digital transformation within for civil and infrastructure is sort of mitigated. Although now we're seeing, of course, the notion of digital twins and so forth, sort of transformation on large scales, both territorially but also organizationally, is more and more prevalent. So our objective with our research project, remember it's a 2-year research project. There was a team, so the Marie, James, Lapam. We had one PhD student, Caïs Ben-Abderrahman. We had a master's student, Megan Dumé, and a postdoc that helped Antonin Pavard while he was here. It was to support a large public organization in designing and piloting a deployment framework for the adoption and implementation of BIM. So again, this organization had been using technologies for decades, but BIM sort of came in a point. Ivanka spoke to the Quebec roadmap. They're part of the roadmap where they had to look at how do they integrate into this governmental initiative, how can they leverage this new approach. So our objectives were to, of course, look at, establish the current and desired BIM state, identify the actions, so not the outcomes. I think that was interesting. Looking at the actions, decisions lead to actions that hopefully lead to outcomes. Sometimes the outcomes are different from what we're supposed to achieve. Raise awareness. So a key thing was engaging and raising awareness across the organization. So we're talking about an 8,000 person organization, so very considerable, and it's distributed across the Quebec territory. Identify and implement pilot projects, so testing and evolving, and basically targeting and developing the resources and core competencies. We did 2 axes, so very rapidly. We looked at the organizational level and, of course, at the project level. And this was sort of the key in trying to interrelate between both levels. As we're looking at BIM adoption, BIM implementation at the enterprise level, organization level. It's a huge transformation, long scale, but it's manifested through projects. And of course, then into the asset management phase. So when we look at the stream, our detailed research approach for stream 1 at the organizational level, a lot of action, a lot of activities. One thing is that we did position this in an action design research approach as proposed by SIGN. This was to co-construct the intervention. We didn't want to come and say, as researchers, this is what action research, this is what we need to do. We were really wanting to, cognizant that the organization had its culture, had its approach, had its particular language and practices, so we were designing the intervention with the organization itself. And you sort of see where we looked at, we were looking at documentation, interviews, diagnostics, workshops, and really today what we're talking about is really just the workshops, this notion of co-construction and common making, sense making and perspective taking as we were talking a bit earlier. And then one thing we looked at is looking at what are the existing frameworks. So the Quebec roadmap is an existing framework. And, symbiosis, I think this notion of putting human-centric transformation, we positioned that the human at the beginning, at the center of this transformation. And we looked at the different elements that were making up sort of our approach. We looked at practices, we looked at the services that were offered and how those are being transformed, looking at frameworks, existing frameworks across the globe, and then specific competencies for transformation. So I'll then let Marie, who's, again, she's coming at this from an organizational communication perspective and brought the notion of the socio-technical perspective and point passage obligé. So I'll let Marie take over.
Okay, hi everyone. Can you hear me well?
Yep.
It's okay? Okay, great. So since we present the workshop phases, we rooted it in a social technical perspective. So basically, since BIM, from my colleague perspective, is a set of technologies, processes, and policies enabling multiple stakeholders to collaboratively design, construct, and operate an infrastructure. Could be a road, a building in virtual space. We follow Erik Lindrod's perspective, who proposed in 2010 to consider the adoption and use of BIM as the interlinkage of actants, so networks, forming a building and construction project. So he uncovered the mechanism facilitating and constraining the creation of actor networks in which BIM is adopted and used. So he proposed that BIM can be seen as an actor network or multiple actor networks composed of humans and non-human actants. So such as, well, humans, such as directors, practitioners, a research team, or non-humans, which is the socio-technical perspective, such as infrastructure, technologies, processes, policies. So these actors are interconnected in time and space and can be called into question at any time. And most importantly, they interact around a common issue, often with different and sometimes contradictory objectives. So if we problematize the situation of these interconnected actants, humans and non-humans, how they are interacting within this network to reach their respective and sometimes contradictory objectives. So these actants need to position and organize themselves through one or multiple obligatory passage point. In other words, it's an inescapable statement towards which the actants organize themselves to overcome the obstacles and converge in order to achieve their respective multiple objectives. So according to Calon, this is really important. So that leads to a translation process. So the actants which evolve in these actor network are linked to a translation process. And to succeed, this process depends on spokesperson and we have to go through several tests. So how we perform collaborative workshops to consider that social technical perspective. So Erik, your turn.
All right, thanks, Marie. So we'll go really fast because we don't have much time, but essentially this notion, I think it brings a new light. BIM as a socio-technical perspective has been around for a while, as Marie said, but how do you actually operationalize this? How do you make it actually work? So through a series of workshops, so you sort of see around 100 people per series were involved. The idea here was to look at alignments. So we had multiple ways to go and collect feedback and try to translate, as Marie was saying, these expectations, these issues, these challenges that people were facing with digital transformation. And then we had them, we organized them, we had them prioritized. So it was this continuous engagement around creating dialogue, creating common notions around transformation and BIM adoption. So this was really what we were looking at in terms of this notion of obligatory passage point. And I think this is really the contribution here as saying, sense making. How do we, in perspective taking, how do we come up with alignment, converge on common needs to undertake the transformation? And from this, so basically these are the questions we were asking. This is the way that we structured our workshop. So very quickly, we looked at, we found hundreds and hundreds of actions, hundreds and hundreds of elements that to be included basically the outcome was to develop a organizational roadmap. We did that with a steering committee. We came up with the same work, and ultimately then tried to compare. And so this is, again, the key thing is around the obligatory passage point, and I'll stay here. Looking at, we had steering committee members, we had sort of direction, upper management and their perspectives. So you see in the dark blue, steering committee, and the light blue were the operational people. So they're the workshops, the 3 workshops that we did. And we were looking at misalignment and alignment around this framework. So saying, for instance, piloting and coordination, mobilization competencies were much more prevalent as an obligatory passage point for steering committee, upper management, rather than the expertise or the operational, whereas processes, technical systems were more of a consideration for these things. So what we saw basically at the end of the day is that this approach allowed us to sort of lay flat across the organization the considerations. So first off, the action design research approach allowed us to co-construct the intervention. The obligatory passage point supports consideration of human and non-human actants, so operationalize the BIM as a socio-technical system, looking at involving the key actants in the process. We use the workshops to identify and prioritize actions to be undertaken by the organization. Complementary perspectives, so not misalignments. I think it was just a notion of different perspectives and laying them flat. Again, that was the key point here. So it's larger, and of course the initiative is part of a larger initiative aiming to structure and guide large-scale BIM adoption and implementation within a large public organization. Whew, thank you.
No time for questions. Well, we might have time during the coffee break, which will be in 10 minutes. So next presentation will be by Mauricio, who is a PhD candidate. Thank you very much.
So, thank you so much. I'm Mauricio Ramirez, and my presentation is to propose a maturity model to integrate lean construction and digital twin for construction monitoring. So, this is a plan of the presentation. The background behind this idea is
I seem to have a problem in the sharing. Okay. Do you see it now? Okay. Okay, attends. Okay now? Okay. Sorry about that. Okay.
okay. So the idea of this integration is to fight against the low productivity problem. So in the literature, we can identify in the literature, we can identify 2 approaches to fight against this problem. One is the managerial approach, the other is the technological approach. In the managerial approach, there are some tools, methods, and techniques, and in the technological tool, as CAD being C4.0 and digital twin. So at the beginning of this research, we explored the possibilities to contribute to this integration, starting with digital twin, but then we realized that lean construction can be a very interesting combination for that. So the first question was, can DT and LC create a synergy? So we explored this feasibility, and we found the alignment between DT functionalities and LC principles. The benefits of DT from this synergy is that LC can increase the value of DT in the execution by defining the information requirements. In the other side, the benefits of LC from this synergy is that LC implementation can be technologically supported and enhanced by digital twins. So the motivation is that normally we use some construction management function as allocation and control to improve productivity. But when we use lean construction, we have some barriers like fragmented implementation or difficulties in information management. If we use digital twin, we have also some challenge as the low awareness about the value of digital twin, the no integration with supply chain, and also the focus only in the geometric information. So to use both together, we have also one important challenge, that is what kind of DT-LC system can we use. To do that, we have to think about the type of integration, the lean necessities, and DT capacities. So for that, we propose a maturity model to allow a construction of smooth flow and the ability of timely and accurately work progress information. So the idea is to develop a maturity model. A maturity model analyze the level of the completion or certification of a method, technique, or concept, and describe also the steps to transit from the lowest to the highest stage of knowledge. So in construction, we found, for example, a maturity model proposed by Arut with 4 criteria: autonomy, intelligence, learning, and fidelity, distributed in 5 levels. Concerning lean construction, most of the maturity models only measure the level of implementation or the degree of knowledge about principles and methods. So to enable this integration, we propose technology as the element that allow the articulation between digital twin and LC. But in literature, none of the reviewed lean construction maturity models relate technology with lean construction. Fortunately, we found one concept about technology and lean proposed by Sugra. So our proposal is a maturity model with 2 components. One is the matrix, the second is a table of functionalities. So the matrix is in the way axis, we have the level of digitization or the level of use of technology to run a lean process. So Sugra Lean proposed 5 levels. We take 4 levels in our proposition. We are inspired in these 4 levels. So he proposed the analog, digital, and smart and autonomous levels, depending on the use or not of technologies. For example, in analog, he proposed the use of sticky note and Kanban cards, and in the final, the autonomous, he proposed the use of smart equipment to collect and run a lean process. In the other side, in the horizontal axis, we propose 4 levels of digital twin, or 4 maturity levels for this digital twin that will take information for lean construction process. So these levels are inspired in some other concepts, as, for example, the data integration level of Krisinger, the degree of automation proposed by Zucker and Poirier, and also in the Arut maturity model for DT in construction. So in these 4 levels, for example, the first level is called assisted digital model because it uses the concept of digital model proposed by Krisinger, when information between the physical part and the virtual part is done manually, not with technology. Assisted is the way that we can collect information for the process. So in this, level, we need the intervention of humans. So based on that, we propose this matrix of synergy. We identify two main parts. The first is the diagonal, when we merge the digital twin capacities with the link construction necessities. And the other important part here is an area called zone of inefficient integration. That means that, for example, if we use an automatic digital twin with a huge technologies with powerful functions, and the other side we only need some analog link information, we generate waste. For that, this is inefficient integration, but in the diagonal is the more harmonious possibilities, because are in the same level the capacities of the digital twin and the necessities of the link process. The second part, the second component is this table of functionalities. So this table is inspired in the former matrix, and also in the concept of the digital twin in infrastructure or civil infrastructure proposed by Naderi. So we define the functions for each digital twin according to three main kind of technologies. These technologies proposed by Naderi are the collection data technologies, the data processing technologies, and the information model. So in each model is described the way as a digital twin used to inform link construction can collect, can process, and can visualize this information. So, for example, in the data collection, we propose 4 levels for each type of synergy, and we, for example, describe the way that data can be collected. For example, in the first level, data is collected basically manually, and in the final level, in a full synergy, data is collected using automatic ways. So this table, for example, describe a little the level of automation of this digital twin, and we can compare this with the proposition of Arup in terms of autonomy of a digital twin. In the second data processing, we describe how this digital twin can use analytics from, for example, in the first level, the use of Excel sheets to arrive to a final use of advanced analytics. So we can compare this with the concept of the intelligence in digital twins, also proposed by Arup. And finally, in the information model, we describe how we can imagine that data is visualized for the user, for the final user. For example, in this level, we propose the use of CAD platforms to visualize information in 2D. In the final level, we propose the use of the platform to integrate LC information with 3D geometric information and georeference too. So, to conclude, we can say that DT and LC integration can enhance productivity, but we need more details to do this implementation in practical case. For that, we propose this maturity model to encourage practical joint implementation. So finally, this implementation needs to be carried out progressively, ideally following the proposed synergy levels to mitigate the risk of failure. This risk is because when I say we use an automatic digital twin only to collect some basic information from link, is waste of money and waste of technology. So future work can be done well, limitation, we need more information about the technologies and data requirement to implement this maturity model. And for future work, we propose develop these technologies and tools to also we propose pilot projects to offer insights into the quantitative and qualitative benefits, drawbacks, and challenge for this integration. So this is the bibliography. Thank you for our partners, and thank you so much.
Thank you very much, Mauricio. So we're 5 minutes over with the time, but now we have a coffee break. Let's say we start again in 10 minutes, and you can ask your questions to the last presenters just by meeting them. Why not? Or you can keep the questions also for the last hour of today's workshop. And online, you can write your questions, and we'll ask them in an appropriate moment. Thank you, everybody. Rebonjour tout le monde. Hello everybody. We'll be continuing the session. I'm just inviting everybody who is in presence to come back to their seats. And we have our second keynote speaker, Farook Hamzeh, from the University of Alberta, who should be online. Farook, can you take the floor and share your slides, please? Okay, I can see you. I'll try to show you a picture also. I mean, not your picture, but your video. Okay, this should be possible.
You see my screen?
Yes, we see the screen and also you. Okay, wonderful. Thank you so much for accepting to give this keynote. And the floor is yours.
Good morning, good evening, good afternoon, wherever you are. First, I want to thank Professors Jordanova and Erik Poirier for inviting me. So today I'm going to be talking about this need for a human-centric approach to construction 4.0 technologies. A little bit about me. Just briefly, I finished my PhD at University of California, Berkeley. And after that, I went to Colorado State University. Then I went back to my alma mater, American University of Beirut. Then I joined the University of Alberta in 2019. So a little bit about my professional experience. This is the project, which is the Van Ness, or what's called Caterina Hospital. The name has been changed to Van Ness, which is one of the most model projects. Really, it's an ideal project in terms of the application of BIM and Lean and the integration of digital technologies on this project, which was also delivered in an IPD format, not IPD-ish, IPD, full IPD. I would say that all the elements of IPD were already on full display in this project. So before that, I worked on several projects all over the world in Lebanon, Dubai, and Qatar. Here are just some examples. This is the Losail track in Qatar, where we're doing this track, which now is a Formula One racetrack. This is the Education City, also in Qatar, which houses several US-based universities like Will Cornell, Texas A&M, etc. This is the Rose Tower in downtown Dubai, which was also a very challenging project, built with a very tight schedule. We're building one floor in 3 days. Very, very, very special project. So this is a little bit about me, about my experience. But today I'm going to be talking about other things. So this is kind of the agenda. I'll start with the current challenges. I'll talk a little bit about construction 4.0. Then I'll talk about the challenges and opportunities and the need for the human-centric approach. And then we're going to end with some questions. So sorry if I'm looking a little bit sideways. I have a small screen here, and I have the big screen here to the side. So I'll try to be looking this way most of the time. So how many of you have been using ChatGPT and you know its capabilities? It has really amazing capabilities in terms of answering things. However, we all know about what's called the hallucinations that sometimes you can get some really funny answers. For example, if you check, for example, one of the things is that for a PhD defense, they say that you have to fight a snake. So probably somebody put in there in the web that you have to fight a snake. So for PhD students in the room, don't be afraid. You don't have to fight a snake in your PhD defense. It's just that this is some of the answers that maybe ChatGPT will give you. So anyway, we all know how AI is, moving very fast. and taking more prominent role in our work and in our life. So what's happening is that the degree and the speed of technology is much faster, happening at a faster pace than the pace of us sitting down and thinking of the implications of what the humanity is doing. But there are some philosophers and thinkers in the world that sat down and thought of it. One of them is Noam Chomsky, who's a leading thinker in the world. So what he said is that today our supposedly revolutionary advancement in artificial intelligence are indeed cause for both concern and optimism. Optimism because intelligence is the means by which we solve problems. Concern because we fear that the most popular and fashionable strain of AI, machine learning, will degrade our science and debase our ethics by incorporating into our technology a fundamentally flawed conception of language and knowledge. So you see, there are concerns from these philosophers, thinkers in the world, and we need to take them seriously. This slide shows the taxonomy of Education 4.0 taxonomy by the World Economic Forum, which shows what are the kind of skills that the future students should know, right? And we see here there is level 1, level 2, level 3. You have abilities and skills, attitudes and values, and knowledge and information. As you see, in the level 2, you go to cognitive, social, physical, self-regulatory, societal, and disciplinary knowledge. And on the right, you see that what the student should know, should have creativity, critical skills, digital skills, problem solving, collaboration, negotiation, socio-emotional awareness, all of those things. You know, so how you gonna? The question is that will the use of the extreme use of these technologies, will it erode some of those capabilities? And this is a question. And as you see here, in short, the future of education lies in empowering young learners to embrace and develop their uniquely human qualities, those unlikely to ever be replaced by technology. So we have to be very cognizant of these things. How many of you are familiar with Martin Heidegger, Discourse on Thinking, 1959? So what Heidegger says in his book, he says that modern man, modern human, is in a flight from thinking. So when you hear this sentence, modern man is in a flight from thinking, you will be thinking, what do you mean? Like we're thinking less? No, this is not what he meant. He distinguished between two types of thinking. One he called calculative thinking, and one he called meditative thinking. So calculative thinking is the one based on logic. This is the one where you use for planning, for scheduling, actually. For scheduling, use it for solving issues. But then the meditative thinking is the one that is based on intuition, the one that is kind of has all the subtle things in the human being. And what he meant that a human is in a flight from meditative thinking towards calculative thinking. So, so man is now becoming closer and closer, thinking in only based on logic and less based on intuition. And unfortunately, we are building machines that resemble this part of ourselves. So these machines and even machine learning, even the algorithms that we are building, resemble this aspect of us. So this idea of Heidegger that we need to balance these two types of thinking in our advancement, then it needs to be important. You see here, for example, contemplation between activities aids in the development of sound conclusions. And this is a human aspect that requires this type of meditative thinking that we are losing as we are depending more and more on technology. So I will talk a little bit about the introduction to Lean Construction 4.0. And first, I want to talk a little bit about Construction 4.0. Or first, I'm going to start by Industry 4.0. So as you have seen, you know, we have this progression first with Industry 4.0, with steam power, with the loom, mechanization, the advent of mechanization. This was the first revolution. Then the second one with the Industry 2.0 with mass production, assembly lines, electrical energy. And then we start to move to Industry 3.0 with automation, computers, electronics. Then Industry 4.0, you know, where we are in today with cyber physical systems, Internet of Things, networks, AI, cloud computing, Internet of Things, etc. There is 5.0, but I will talk about it towards the end. So what about construction 4.0? It is the use. It is partial use, because in construction, some people kind of debate that we are not in 4.0 yet in construction. We're still in kind of 3.0 based on the technologies that we are implementing in our world today. However, once we start implementing 4.0, then we will be using more machine learning, AI, computer simulation modeling, cyber-physical systems, digital twins, etc. So what I'm going to be presenting next will be based on our book with Professor Vicente Gonzalez and Professor Luis Fernando Alarcón, Lean Construction 4.0, Driving a Digital Revolution of Production Management in the AEC Industry, which was published last year at the end of 2023. So in this book, we show how this progression, from Toyota product development to lean thinking layers, Industry 4.0, Lean 4.0, where we suggest an idea, we call it Lean Construction 4.0, and we didn't want to call it 5.0 because we didn't want to keep on piling on the numbers. But this idea of Lean Construction 4.0 is built on 3 legs of the stool, which are people culture, and for us, people culture is the most important. Everything else is also important, but this is the foundational piece, is the culture you build. As you're familiar with the famous quote by Peter Drucker, is that culture eat any type of techniques or methodologies or tactics or strategies for breakfast. So culture trumps every other card. So if you don't have the culture, then it's going to be difficult. So you need to develop the people, you need to focus on culture. Next is a process or philosophy. What type of processes are there? Do you have a system to manage your company or your project? And the third is the use of technology and how technology is kind of invested in here. Definitely, there is the fourth element, which is kind of embedded in those, which is the idea of sustainable environment. Is we have to do all those 3 while maintaining the continuous presence of us as human beings on this planet. So all of these 3 have to happen also within the elements of sustainability. What I want to warn about is that people have been lately focusing so much on one leg of this triangle, which is technology, and they're ignoring processes and ignoring kind of the impact of people and culture in the equation. And I see most of the research lately that has been happening is that people just focus on one element, one of these legs. I've been into CRC last year, and I've seen the enormous focus on technology and less on the other 2, or integration of these 3 together. And our goal is to bring this into the mainstream, that we need to focus on these 3 together. I want to talk a little bit about the challenges and opportunities of construction 4.0 technologies. And here in this talk, I'm going to summarize those into 4 types of technologies, which are digitalization, automation, smart environment, and system integration. So I'm going to divide all of these Industry 4.0 technologies into these 4 families and discuss them just a little bit more to bring the issues to surface. So we'll start with digitalization. Here we're talking about the Internet of Things, big data and analytics, cloud computing, blockchain, augmented and virtual reality, 3D scanning, video capturing, etc. There are more. So these are great technologies, but they, like with every technology, it comes with challenges. So these use a lot of energy. There are huge servers that are taking a lot of energy, and most of those are powered by non-clean energy. So the more we are using actually these technologies, we are drawing on non-clean energy, because these huge data centers and huge energy, they require huge energy, and this energy mostly is not coming from clean and from clean energy sources. Other issues are related to cybersecurity, employee surveillance, data privacy. As you know, the biggest companies in the world nowadays are data companies, not necessarily brick and mortar companies. And we see more and more brick and mortar companies are losing their presence to more of data companies. Well, with each challenge, there's an opportunity. So the opportunities are that we can implement lean principles with the use of those. We can use it for better stakeholder improvement, hopefully better improved productivity, better transparency, better trust, if it is used in the proper way and if we apply the human aspects into that. Next, I want to talk about automation. And here we're talking about robots, whether they are on-site or off-site in terms of off-site construction, or whether it is additive manufacturing, 3D concrete printing, 3D material printing, steel printing, etc. All of this additive manufacturing, the use of drones, the use of autonomous vehicles, etc. On-site, which is all of these technologies, they have a lot of what you call impacts. Some of the challenges is the increased energy consumption. I mentioned that. Some are afraid of that we're going to lose some blue-collar jobs. Some are saying that the small and medium enterprises will be at a disadvantage, and maybe local firms will be also at a disadvantage to huge international mega firms that will have a bigger play. Some will say that there will be a big wage disparity also. Well, with each challenge, as you said, there comes opportunities. The opportunities are maybe improved productivity, reduced material usage, reduce errors, especially with automation, reduce worker fatigue probably, and reduce productivity, hopefully reduce the gender gap. Hopefully with the use of robotics and automation, we're going to see more of both genders working in the field of construction engineering and management. And hopefully this will bring much more parity between the genders and much more equity and diversity. Oh, this is what we hope. Now, in terms of integration and collaboration, this family of technologies, I'm going to talk about digital twins that are used more and more. Simulation has been there for a while. Cyber physical systems, these are digital twins, but they are automatically managed using engines, using algorithms. We have so many of these systems right now already in practice. I know there is a major company in the US that has been using these cyber physical systems to hire and fire people. So you are hired by an algorithm and you're fired by an algorithm. That's really strange, and it's raising a lot of questions, ethical questions. Building information modeling, blockchain, smart contracts, etc. As we said, some of the challenges, I mentioned those, maybe reduce creativity by employees. Some people are raising that. They're saying extra power to technology firms. On the other hand, there are some opportunities. Now there is dynamic control over projects. There's a lot of opportunities to optimize construction projects, better stakeholder collaboration, hopefully. And hopefully there's an opportunity that we implement lean construction principles. Last family of technologies that I want to talk about today is smart environment. Here we're talking about smart cities, AI, smart construction, augmented reality, virtual reality, holographic displays, etc. Smart materials, machine learning, all of this is under this. As we said, some of the challenges are the need for bigger data centers. The more we're using those, we need those big data centers that are using non-clean technology and non-renewable technology as of today. Some people are concerned with reduced employee autonomy and creativity, lower employee self-actualization and worth. Now, how will the employees feel in terms of psychologically? What is their morale, etc.? These are some of the challenges. Some of the opportunities, definitely improve productivity, improve transparency and trust, and better stakeholder involvement. So as you have seen, these families of technologies, they have a lot of challenges, but also they promise a lot of improvements. However, we as researchers, we want to bring into perspective that these might have impacts on the human. So we have social impacts on the individuals. So we have the risk of replacing these blue-collar jobs. There is the risk of limiting employees' creativity. Are we going to be now is this going to help with increasing or reducing? Some people are saying by us having more automation, probably this will leave us some time to be more creative. I hope so. Let's see. But these are some of the concerns. Some of the concerns are reducing the human self-worth and morale. Now you are part of this new modern organization. You're working with AI algorithms. You don't know if the algorithm, if you're gonna be hired or fired by an algorithm. How would you feel if you're, working for a company and you don't deal with any superior? All what you get a message from an algorithm that will tell you if you're hired or fired, or tell you about your promotion or whatever. How would you feel in terms of self-worth and morale? The others that I have seen also, especially from the architects, is that marginalizing architects' work in addition to art and culture. So what is the impact on art and culture, especially that now with the ability of AI also to reproduce art and other artistic kind of outcomes that were only thought that only humans can do. So what are the impacts on the social structures? Danger of running SMEs out of business, I mentioned that before, and more monopolization by larger companies. We end up just with these mega companies that are running the world. So this is one of the concerns. Over-reliance on technology, impeding cognitive thinking and reflection. And this is echoing what many philosophers, leading thinkers are saying. How will that impact us? Not now, maybe 10, 20, 30 years into the future. Will that reduce our ability to do cognitive thinking, reflection, and in the words of Martin Heidegger, that meditative thinking? Then we have other things like ethical, moral, and social dilemmas. And as you have seen today, you read in the news, everybody is asking that there should be a code of standards for the use of AI and digital technology in the world. Because right now we don't have a formal code that kind of puts everything into perspective and puts what are the rules and regulations and policies for this. How many of you have read this book, Limitless, by Jim Quick? Anyone have read Jim Quick? So if you haven't read, I really advise you to read this book, Limitless. It talks about the ability of improving our brains, how we can have our brains run better. What he says, he uses in his book two terms that he uses: digital dementia, which is the breakdown of cognitive abilities. Imagine that, for example, in the past you used to use calculator to think. Now you don't use it anymore. Now we don't. Now we cannot. Some people can't add even two numbers. Would that happen to us? Like, imagine structural engineers. After a while, they don't even remember where's the maximum moment on a beam. I think that will happen, because with our over-reliance on technology and on AI to design for us buildings, and this is what's going to happen, is happening now, actually. Will that actually break down cognitive abilities? And this is what Jim Quick is mentioning as digital dementia. Then the other thing is digital deduction. Would we also subcontract our capability of deduction? Because now we're letting these algorithms and these machines do the thinking for us. We lose our capability of deduction. And the questions that we ask, and we ask in the question in the paper that we published in 2022 in RGNC, how can the industry innovate, evolve, create, and thrive once such skills are being automated? Wouldn't that limit our abilities? So these are questions that have to be asked as we go on. Here, I want to bring us back to our basics. And I think Professor Koskela today was talking about some of these issues, is that this idea of how do we look at our production systems? We have different types of looking at it. If we look at it as only as production, which is called the production-centric view, as you see on the right, only focuses on the physical aspects of production, like flows, transformation, management practices, processes, technology. If we're only thinking of construction projects as that, then we're only seeing only one aspect of it. The other aspect is that projects are sociocentric. The sociocentric view it says that there are people's behaviors, individuals at different levels, their interactions on a project. And this is the research that we have seen today, also a little bit about value. One of the students was also presenting about value. So these are very important aspects that we need to look at construction projects as socio plus a production centric. So we can't look at only socio-centric. This slide shows a little bit about research about the use of AI in construction. And this is one paper that was published in IGLC, which shows that with the use of AI, especially in scheduling and in well, there was some positive outcomes. There was a reduction in project duration, labor saving, and equipment cost savings. This is one of the case studies that was presented. However, what they say is that there's no transparency in how the activities were scheduled. There's a reduction in the sense of achievement and ownership of the users. There's no consideration for team dynamics and collaboration nature on construction projects. So these are some of the concerns that were brought up by the researchers, and you can read that paper in IGLC actually. And then we have this idea of investigative of AI, and we want to investigate, you know, what AIs are capable of. These algorithms that hire and fire people, how do they do that? So sometimes there's lack of transparency. There are challenges in collaborating in a team environment. There's a lack of ability to negotiate and interpret signals of status and intentions. You don't know what's the intentions. If you're working with a company that actually there is an AI algorithm that will hire you and fire you, you wouldn't know if you're doing well, you're not doing well. You just get, you know, thank you so much, you're fired. Okay, well, you didn't know, you didn't see that coming. You didn't have. So this, I think, creates a different type of environment, and this will have impact on motivation and team structure. How many of you have watched the Peter Haas TED Talk? If you haven't, please, I've shown the link at the bottom of the slide. You can watch Peter Haas talk on TED Talk. I'm not going to show the video today, but I'm going to give some highlights from this talk. And this guy is one of one of the what you call leaders in the field of technology and AI. He's not a guy who is from an outsider. He's not kind of like me. He's whose basic construction or his basic competitiveness or competitive skills are technology. So this is what he says. He says that what bothers him is distrust. He says it's distrust that bothers me, not because how often AI gets it wrong. It is how badly it gets it wrong when it makes a mistake that has me worried. These systems do not fail gracefully. So when we have the self-reliance on the system, and the system will have to fail sometimes. But what he's saying, what Peter Haas is saying, is that when these systems fail, they don't fail gracefully. They fail catastrophically, in a catastrophic manner. And this is what gets him worried. So that's why, you know, what he says, we need to lead, not follow. We need to choose to be less like robots, and we need to build the robots to be more like people, because ultimately the only thing we need to fear is not killer robots, it's our own intellectual laziness. And this is what he's worried about, that because of our intellectual laziness, we're gonna give the reins to robots and AI, and then when they fail, they're gonna fail catastrophically. So as you see, you know, there is opportunities and challenges like everything in life, but from lean construction, what we learn with the principle 1 and principle 8 from lean thinking, we say base your management decisions on long-term philosophy, even at the expense of short-term financial goals. Principle 8, use only reliable, thoroughly tested technology that serves your people and processes. And the focus on serves people and processes. These are very important ideas. And this is what we mentioned in our book, and I mentioned about the 3 foundations. Hence, this brings about this need for a human-centered role. And here I'm giving an example about a human-centered design. So we need to move into different levels of engagement, the human-centered activity. I just gave an example of a human-centered design. You can start, for example, on the left with empathic design, having people you are designing in mind, which is nice to have empathy, but you can have more. You can have participatory design, where you're involving the user in the design. And this is what I'm advocating for. If we have a human-centered system, this means the users are already part of it. Then we have the third one, which is called contextual design, which is basically understanding how the customer works. And the last one is inclusive design, which is allowing the greatest number of people to use and be involved in that product. This brings me into this idea of Industry 5.0, which adds to Industry 4.0 three elements. These are the elements of a human-centric, sustainability, and resilience. And I can't emphasize those enough. And these three elements are already embedded in our Lean Construction 4.0 model. But in terms of the industry, they are under Industry 5.0. So our systems should be human-centric, should be sustainable, should be resilient. So when they fail gracefully. They don't fail catastrophically. What is about the future? These are going to end. These are towards the end. So there are risks. What are those risks? I mentioned replacing blue collar, limiting employee creativity, reducing human self-worth, marginalizing architects' design or artists, focusing on technical aspects without focusing on the human aspects, ethical factors, psychological safety. How many people are talking about psychological safety, the impacts of those? What about rewiring a human brain to reduce compassion? This is a big one. It says that maybe with all of this use of technology, humans would kind of have a reduced compassion for other living systems. So these are some of the concerns that we bring about. The next is, what about the implementation issues? Like, before we are building these systems, are we thinking about how we're going to implement them? Are we thinking what's going to happen in the future? For example, do we have standardized methods to study the impact of technology, or to assess the impact of this technology adoption on workers and employees? Do we have these methods for radical change? Did we include the workers and employees in designing these new systems and processes? Did we design these new processes without compromising the creativity or the humanness of the humans and morale? Did we design them to reduce harm? Or we're gonna just build those systems and later on we'll see what happens? Did we think of which jobs will be affected and which new skills do we need to be acquired and will have to be trained for new people? How are we going to train people to fit the needs of the new processes? These are questions that we are asking. I'm going to give here an example of how we as researchers, we're bringing this idea of technology, but we're bringing the human aspect into it. And here I'm going to talk about this project that we're working on, which is called Cognitive-Based Resource Allocation Framework and Construction, a Data-Driven Approach, by my PhD student, Lynn Shahab, supervised by myself and Dr. Gang Lee. So in this study, what we're doing, we know that there is, in the industry, in the real world, we need some cognitive skills for the people in the field of engineering, construction, and architecture. And we are measuring those from the cognitive abilities, from the human perspective, from the way the cognition happens in our mind. So, and this must be quantified. And this is what we're doing. We're quantifying those demands so that we assess the capabilities of people and so that we can put the best people for the best job. And here we're doing the study, and we are basically having those assessments with people. I know at least there is 1 or 2 people in this room and online today who have already done these tests, and I want to say thanks to you who have been involved in the study. And our goal at the end of the day is to understand how people work within different complexity levels on the project and within different stress levels. And how is it that we will be able to use the best skills and we predict the successful outcomes of a task on projects. So this is all what I wanted to share with you today, and I hope that kind of I provoked you to ask some questions and to think of those issues that we're going to be having with Industry 4.0 technologies and Construction 4.0.
Thank you very much. I hope you heard the applause here. A very thought-provoking presentation. Questions? Maybe there are some questions online? Yes, Dominic. He always has questions, yeah. I was going to say the comment, but he did it.
Good morning, Farook. It's Dominic. Professor Koskela talked about the issues with having no clear boundaries between engineering and economics when it comes to production theory. And you talk about how we have been, probably since Adam Smith and even with the work of Frederick Taylor, push the workers on the side and thinking that we can organize their work and not really use their creativity to optimize processes. So I've been puzzled by this question for a while, and I do wonder if you have any insight as to why is it that you know, we tend to, or we try to remove workers from the process. And then in one of your slides you said, and then we want to try to create robots that resemble humans, right? So we're not interested in humans, but we create technology that needs to mimic what humans are doing. So I just wonder if you have any insight as to why that is happening.
Well, I don't, maybe I wouldn't put my finger on the wound exactly, but there are so many things, you know, many of those things are driven by the promise of technology to deliver us. Like many people now believe that the solution is technological. And, you know, with all the problems we have in the world in terms of how we're using our resources, in terms of our productivity, how we're using the resources on this planet. So most of the people, like they think that the solution is technological. Well, you know, me and you and the rest of the people in this room, we know that the solution is not technological. The solution is a human. The solution is on the human. The solution is culture more than technological. But for those people who push the technology agenda, this is what they're doing. And in doing those things, they are moving very fast forward without relying on this buy-in from humans. Like who asked you or me, you know, before putting all of these technologies there? Did somebody check the what it's gonna create on humans? If you're all familiar with the famous writer Isaac Asimov, who is a famous, you know, what you call a sci-fi writer. He's the one who came up with these rules for any digital machines. They should have rules. They should have ethical rules. At least he thought of them. Now, how many of us are thinking of these ethical rules that we should have for cyber physical systems? Nobody is talking about those. So I don't have an answer to what you're saying. I feel that one part of it is the push for efficiency, the push for you know, economical gain faster. Like we want to be much more efficient faster without thinking about the impact of that. It is that push for productivity, for the push to make money. It is that greed, I would say, part of it, without us thinking about the impacts of them. We say, okay, we build them and we'll think of their impacts later. But we know, like the same thing with asbestos. We build all these buildings, and later on we discovered that asbestos is deadly for the human. And then we started removing all of these buildings that we built in the 60s that had asbestos in them. I hope we're not building some systems that are similar to this asbestos in the way that we're doing, and then we need later on to remove them 20 or 30 years down the road. Then it will be very difficult to remove them. I know that I did not answer your question 100%, but it is a topic for discussion.
Yeah, absolutely. Topic for discussion. Yes.
I'll say I'll be happy to have a coffee. My suggestion is that humans are not, cannot be inscribed on the asset side of balance sheets. They are expenses, whereas technology and assets can be placed on the asset side of balance sheet. So you can create apparent wealth economically with technology and asset, whereas with people it is difficult to do so. Just from an economic perspective. Okay.
Another question by Louis Parent.
Good morning to you. Always a pleasure to see you, Dr. Hamzeh, in your presentation. So I'm curious about the three pillars. I understand the people and the culture. The technology is the easy part of it. I'm wondering why philosophy went into process, where typically process you'll have standardization, methods, tools, and you've put under the pillar process philosophy, and found that lean construction is hard to implement because we're trying to sell a philosophy when there's tools to implementing it. So I'm curious why.
Yep, that's a very good question, Louis. So the idea behind it is the process is what comes to the forefront, but many of our processes also reflect our philosophy. That's why I put philosophy behind it, but the process is what you will see. Like when we go into an organization, we can see their processes. We don't see their philosophies. We're only gonna guess whether their philosophy are based on their processes. So this is what I'm saying. I'm saying that those processes should have philosophies behind them. This is what we're trying to say, and we said in the book that even our processes, we cannot just have processes just like what Dominic was asking today. If all our processes are just, for example, for productivity improvement, then where would be the human aspect come in it? If it's all about short-term gain, then we will be like just like those Wall Street CEOs who come in and all what they care is their first quarter gains. They will get their first bonus, $1 million, and next quarter the company goes out of business. They say it's okay. I don't care if the company goes out of business. I'm gonna go to another company. So if we approach our production systems in that way, then our processes will be suboptimal. And this is why I'm saying that the processes are the apparent ones, but the philosophies is what's hidden behind them. And what we're trying to say is that those processes should be guided by those philosophies. I hope I addressed your question.
Thank you.
Thank you for these answers, Professor Hamzeh. Okay, Erik Poirier has a question also.
Thank you, Farook. Very thought-provoking and I think very timely discussion. The Tavistock Institute in the 1940s, investigated the impact of technology on workers and socio-technical systems, and found that in coal mines people were depressed because they were delocalized and they're productive. So I feel like, what can we learn from these studies that were taking place 76 years ago to this day, and is it the same or is it worse because of AI and the scale of digital transformation?
Well, this question is not for me, Erik, it's for all of us, because all of us will have a role to play in coming up with these researchers, with these studies. All of us were doing research in this sphere, and we should be, all of us, bringing research to find the impact of these systems on people, on systems. So that's the goal behind this topic, is to as an invitation to all of us, researchers in this field, is to kind of help the industry, because the industry sometimes they are only looking at the pushing the boundary. Sometimes maybe they're not thinking about the impact of it. But it is the role of us, also the roles of governments, policies around the world, to also have also with the sustainability goals and the UN sustainability goals. Also, we have to be taking those into account when we are implementing those systems. That it is on all of us to kind of come up with these studies. And I hear you. I totally agree with you that we need to be doing those things the same way we have done it when we were studying the impact of these workers working in the mines. Right now, we're not working in physical mines. We're working in digital mines. You see what I'm saying, Dirk? So the situation is different. So we need to study also the impact of those. When we haven't understood the full impact of those. Like, look what's happening with our children, the children of the digital age. We're still now starting to learn how technology is impacting them. So we don't have that answer yet. At least I'm talking about myself. We don't have that answer, but we need to conduct this research, all of us, to help guide industry.
Okay, thank you very much for this discussion. I would invite you, Dr. Hamzeh, to come back, if you're not staying during the whole workshop, to absolutely come back at 4 o'clock Montreal time, when we'll be having our co-creation and discussion. So it will be very, very nice to have all of you around, but you specifically because you're raising such pertinent questions. And just, I was thinking about all this also, and I'm thinking, okay, it's the human-centric thought that has to define till where we go, till where we put the boundary of what we're doing with all technology. And now in the next two presentations, we have exactly this kind of research that has been done. Lean and Beam approach in didactic activities by Caterina Ferraro from Florence, from the University of Florence, and hygienic surface material selection for healthcare facilities by Mouhand Abobakr. Sorry for my reading. And Caterina, you have the floor,
Yes.
and you have 10 minutes to present.
I hope you hear me well.
We see you for now. Can you please share
Okay,
the slides?
Yes. Please. Okay, you can see the slides.
Yes, it's perfect. Go ahead.
Perfect. Okay, thank you very much for the opportunity. Good morning to everyone. I'm Caterina Ferraro. I'm industrial PhD student from the University of Florence, and today I will show this presentation with the title Lean and Beam Approach in the Didactic Activities. In the AECO industry, it's increasingly important to consider in the practice and in the development of the design and projects, as we have also seen before, the human factor involved in the processes, and especially focus on the way future practitioner will approach to the Lean and Beam methodology and tools. This led us as a research team to consider the way future practitioners will learn these methodologies and how it is the best way to teach them the proper use of the Lean and Beam combined. So therefore, the question is to find a way of training that is shaped on the human needs, abilities, and peculiarities. This will allow users to learn Lean principles and Lean methodologies more pervasively. Indeed, we must find a teaching process that allows the most effective and deep understanding of methods and tools. So we have identified some approaches for humanizing the Beam and Lean in AECO industry, taking from the human ability to learn from direct experience and manipulation, and from trials and error processes. So the first are didactic simulations, namely modeling of Beam and Lean processes through gamified approaches and replicate them in class. And the second is the flipped class, where the learner is put at the center and has more responsibilities, takes less from the practice and more from the practice than from the theory. Indeed, when confronted with the practical application of Lean principles in the AECO industry, many professionals encounter difficulties. Although it is clear that without precise definition of role, processes, and activities, Beam is less effective, there is still a barrier in the use of Beam associated with the Lean mindset. The work environment requires skilled practitioners, often with early preparation. However, academic and universities courses are not always ensure that students own knowledge about Beam and Lean tools. Nevertheless, lectures, laboratories, and daily didactic activities are the best occasion for students to approach Beam combined with Lean. Furthermore, the structure of some current didactic frameworks is rigid and conservative. As a result, students are neither involved nor interested, and mainly because they have the responsibilities, effort, and involvement removed by one-way lessons, while focusing on their ability, autonomy, and independence would lead to better results. Instead, it is crucial to implement a new approach consisting in creating new didactic processes that involve actively the students interested in learning Lean and Beam. In this sense, the research proposes a flipped class. The aim is to put the students, thus the human factor, in a Lean and Beam process at the center. Indeed, the student takes accountability of the materials produced after receiving work instruction and thus can learn more proficiently and steadily. In fact, the importance of operating directly with the beam and lean methodology and believing in the efficacy of the procedure is fundamental. However, this level of motivation is possible only with extensive knowledge, but most importantly, with direct experience. Taking from the words of the Neofield from an article of 2023, engaging students for more effective teaching does require us to change our pattern. We need to move away from our ingrained, well-honed, received habits of lecturing. We need to adapt to the technical possibilities we now have at hand. Therefore, the principal goal will be to artificially construct an experience of beam and lean combined with the closest to reality simulation. This implies that work groups define specific roles for each member, that instruction from the teacher align with the client requests, and that there is a strict deadline for presenting the final product. Replicating this dynamic in an academic environment leads to increased familiarity with the beam and lean methods. The current research offers limited insight into didactic experimentation regarding lean and beam, thus the necessity to confront this research gap and propose extensive analysis on the academic procedure and teaching methods in different contexts. Previous research has undertaken significant trials to examine the interplay between beam, lean principles, knowledge of these subjects, and their learning. Each of them held great relevance to the direct approach, object manipulation, and finally, real-time observation of processes flow. In these studies, group collaboration is a crucial aspect in the success of the experiment. Among the cognitive aspects of lean practice, collaboration is a core feature. Moreover, communication between different roles within the same group is more important than trust and conflict. The precise definition of activities, responsibilities, and range of actions allows a clearer interplay between stakeholders, and as a result, flows are not disrupted by errors, lack of information, or redundancy. This aspect underscores the importance of teaching, evaluating, and experimenting with the combination of green and lean in a secure environment, such academia and universities, for example, where errors are allowed and failures serve as useful source of data. Yes, okay. To assess the effectiveness of the beam and lean approach, we began by evaluating the progress made by students during a design studio class on construction systems within the Department of Architecture of University of Florence. This studio experience served as an experiment in analyzing the correlation between lean and beam principles in the project design production. The course commenced in October and concluded in December, spanning a total of 5 months, with a final presentation that was scheduled for February the 15th. And the groups were autonomous in developing the designs and according to the objectives set at the beginning of the course. And in this slide, we can see 2 of the final products that were worked by the groups. So initially, the faculty introduced the topic to the class, which focused on creating a digital model of Milano Linate Airport to extract data for students' project proposals aimed at refurbishing and improving energy performance. Students were tasked with defining and selecting project solutions aligned with the sustainability goals and levels of service, considering economic, social, and environmental impacts. So enrolled students teamed up in 7 groups and began following instruction provided by the client, represented by the group of the interdisciplinary professors supervising the design students. As we can see also in this workflow, the 7 groups with their names. And each group selected a specific critical topic, such as thermal insulation, solar irradiation, or water supply management, and proposed project design based on their specific analysis. Furthermore, each group autonomously organized roles, responsibilities, and the division of tasks. Throughout the course, one of the teachers explained elements of BIM and lean management, demonstrating more effective tools to achieve results in less time. Given the limited time frame of the course, the utilization of the digital BIM model held significant importance. How effectively each group utilized the model to extract the necessary information was a critical aspect of the final evaluation. And additionally, since each group had a basic understanding of BIM and lean procedures, proficiency in these areas also factored and contributed to the final assessment of the work. So we can see these are 3 examples of the final proposals. And given that this has been assigned the same topic to all students, seems it was easier to confront also the results. Moreover, a more precise comparison both quantitatively and qualitatively was possible. Each group reacted differently to the teacher's suggestion regarding workflow management, and as you must do, students approach BIM and lean mindset with varying degrees of enthusiasm. Considering the low initial understanding, the perceived usefulness of the BIM and lean method played a crucial role. Consequently, groups that were highly interested and believed in the benefits of the BIM and lean approach achieved better results, both in terms of quantity and quality. However, some groups preferred to stick to traditional methods, opting to work separately with 3D models and CAD blueprints. So, as we can see in the next slide, this is as a team score. So the best groups developed coherent designs and effectively distribute roles and activities among themselves, schedules workflow more efficiently, and extracted all necessary information directly from the model. The quality and quantity of information regarding project design from these groups far surpassed the others. Conversely, the other groups produce incomplete models with minimal information derived from 3D models, resulting in final products marked by inconsistencies. While the available information was sufficient, it lacked depth and coherence across all aspects of the project theme. In this chart, so it's possible to see how the whole and Maverick team, fully committed to the use of BIM and lean processes, reached great results. And whole team especially was able to have more quantity with more quality thanks to the coherence guaranteed by BIM methodology and tools. We are approaching the end of the presentation, and as previously discussed, the educational approach to BIM and lean requires a revision, particularly in environments when BIM practice remains underdeveloped. So drawing from successful experiment, the future implementation of innovative design studios becomes crucial. And this should incorporate gamification features of BIM and lean, process simulations, and provide a comprehensive experience of real case scenarios. This approach aims to enhance engagement, deepen understanding, and bridge the gap between theoretical knowledge and practical application in BIM and lean methodologies. In our experimentation to obtain the needed collaborative environment to use BIM and lean, a more humanized approach seems to be very beneficial. So we are concluding, and the significance of humanized, innovative, and dynamic educational environment is frequently underestimated. However, inclusion, cooperation, and communication to achieve collaboration lie at the heart of constructive interaction in BIM and lean methodologies. So these soft tools should be integral to every professional skills, ideally introduced during the early stage of their career path, preferably while still at university. The opportunity to experience failure is a luxury that academia and university can afford to provide freely. So avoiding its use in favor of entrenched yet obsolete methods could result in missing opportunities for progress and innovation. And so these are some of the reference used for prepare this presentation. And I thank you very much for the attention, and I hope you have maybe some questions, and I'm glad to
Thank you.
answer them.
Thank you very much, Caterina, and also to your co-authors, Maria Antonietta Esposito and Filippo Bossi.
Yes.
We have time for one question, if there is a question in the public or online. Erik has a question, as usual.
Thank you very much. Very interesting, and we're dealing with that, trying to learning by doing. Fundamentally, and this is maybe a belief, BIM can be taught. Information management, its principles, its protocols, its tools, its processes. Lean is more of a philosophy. It's what we teach are the applications. How do you differentiate teaching the tool versus imparting the philosophy to students?
Yeah, yes, you are right. Lean is more like a mindset. So it's like more a model that you create within within yourself, and it's. I think that it's possible to also teach the way, the processes, and like the philosophy behind them. But it's very hard, and it's much more harder than teaching BIM, of course. And it needs some of those human skills and abilities, such as effort or like grit also, and maybe also social collaboration and cooperation that are more impaired in the educational aspect and the social aspect of people. So yeah, I don't have really an answer for this question. It's very complex, but I thank you for the question.
Yeah, that's a very interesting question, and maybe another topic for the discussion later this afternoon. Okay, this was all the time that we had for questions after your presentation, Caterina. Thanks again, and I hope you'll stay till the end of the workshop. And now we have the next presentation also online on the hygienic surface material selection for healthcare facilities by Mouhand Abobakr. Caterina, okay, you stopped sharing. I invite you, Mouhand, to share your screen. I can see you there. You're in UK?
Yes. Can you see my screen now?
Yes, we can see you, and now you should put presenters mode, yeah?
Okay.
Presentation mode, but we see actually, the other screen.
Is this like this way?
You can go, go back to presenters mode. I'll tell you how to change it. Push the presentation mode again. Hello, do you hear me?
Yeah.
Yeah, so hit the presentation mode again, like as it was before.
Mm-hmm.
We don't see the presentation mode yet. Or maybe you can share the other screen if you have two screens.
Okay. Does it work now?
Okay, go on slideshow.
Is it working?
Not yet. It seems to be coming through.
Now?
Okay, now it's fine. It's perfect. Okay, go ahead. You have the floor. 10 minutes presentation.
Right.
Thanks.
Thank you very much. Thank you very much. And I'm really delighted to present my work today here in this workshop. I am Mouhand Abobakr. I am architect by background. I worked as a healthcare architect in industry, and now I'm a PhD student in University of Huddersfield. And today I'm gonna present my work about hygienic surface material selection for healthcare facility, highlighting the structured design decision-making approach. And when we are thinking about humanity and digital lean, it's important to improve the selection process of the material. Whereas, let's say, when we are talking about a human-centric approach that can foster us in the future to improve digital tools that can improve and prioritizing the efficiency and user smooth and easy to use. So today, what I will gonna speak about it's starting just from the broad perspectives, why we are talking about hygienic surface materials, because there is some indications and important indications when we are talking about infection, and especially when we are talking about healthcare associated infection, which is mean when you are go to the hospital to have a treatment and then you get infected by some bacteria or microorganism. So the statistics as per the World Health Organizations, that's showing around 77 million of people that was this, there was a common bacteria infection, whereas when we are talking about US, that we have every 5 minutes a patient that die because of the associated infection in he get it, which is in different way. We are talking about every 1 patient out of 25 patients when they are going to the hospital, they will gonna have infections coming from the hospital. Going more deep, when we are talking about UK, for example, we are talking about between 2016 to 17, estimating 800,000, they get infection through hospitals, and that cost 2.7 billion for the healthcare infrastructure, which is that's represent in 21% of annual number of bed occupations in the healthcare. So we are talking about very important issue that reflect firstly in the human, in death rate, and then we are talking about cost, burdening healthcare system and infrastructure. So just having another glimpse where we are, all of us, we had experience in COVID-19. So up to date, until today, we had almost 7 million cases of death from COVID-19, and we had around 800 million of infection cases. So this is only one type of infections, whereas there's 1,000 of microorganisms that can damage our cell, and that's very, very important aspect. So what I'm focusing it's in my research is to look about from the architecture perspectives. So I'm gonna quote here William Osler, who said, patient almost, they are not dying from their disease they are suffering, but they are dying from the secondary or terminally infections that cause the death. So how we could reduce the infection? This is a really important question, and how we could provide a healthy environmental through architecture design for the hospital, whereas there is a lot of aspects where we can reduce the infections across different disciplinary and across different approach. But I don't think that only solutions will be just to increase the sterilizations in the hospital like this. But we could improve our hygienic surface materials through different approach, one of them through the design and the selection through the design phase of the projects, which is I'm trying to focus in my research. So in my research, I'm trying to focus specifying in critical area, which is we call it ultra hygienic area, which such as ICU, intensive care unit, and operation theaters. Why this is critical area? Because this is creating a crucial factor that sufficiently impact the hygienic level of the space, whereas also this is considered at the high priority to be with a high level of hygiene, whereas a lot of contaminations or microorganisms can be grow there and develop there to produce what we call it nosocomial infection or healthcare associated infection, which will be more harmful than the normal infections. And we saw the statistics at the beginning on the first slide. So this statistics lead me to different research questions. First of all, what the process the designer or architect they do when they are select hygienic surface material for buildings, how can the selection process can be improved, what is actually the definitions of the hygienic surface material and what they are this characteristic of this material, what the impact and influence do the current standard and norm and specifications have in the current situation on this material, and why it's essential to select material that have such features. These questions lead me to put the aim, which is to improve the selection of hygienic surface material and infection control by providing healthcare sectors and stakeholders a decision-making frameworks to select this material by first understanding hygienic surface material and define the definitions of their facility and the selection, to examine the specifications and standard that's currently used in the process of the design and the selection of the material, to group the surface material purity based on their inhibit or support microorganism growth, and to develop last things to develop a new framework that can aid and help the designer with a guideline and criteria to make a proper selection of the hygienic surface materials that align with the requirement of hygiene and healthcare facility. So to do so, I need to first to look about what is decision-making and how decision-making happen in everything in life, whether we are buying a new phone, change the car, whatever we are doing through every decisions we make it daily. So it's going from different stage, which is the first one you will start with alternatives between different options. And then these alternatives lead to a waiting for this alternatives and lead to have a risk evaluation for each option, which is that after need to make decisions and accrue informations and research about these options. And that have to be happen between speed and accuracy. So always what's happening during the construction, as we know, during the construction side, you don't have the sufficient time to do the research or to study each options you have or each alternatives you have. That's what we call it a horse race between trade-off between time and accuracy. That's in the principle of decision-making process. So to reflect that, link it with the research questions with the objectives together, moving forward to study a body of language and how we can investigate to reach this framework, which is divided to a primary and like literature review, interviews, and case study, going from material selections, facility management, understand the microorganism growth, then conducting a different interviews with the practitioners, and then implement this framework in case study for assessment and refine this framework and accuracy performance. So triangulations also it has admitted here to provide a validations for the informations between the literature review and interview and case study, and to monitor the perceptions, the problems, and the process that happen in the way of we are doing a decision making for the selections of the material. So design science approach has been implemented. So in the method of applying and design the framework has been divided to 2 phases. And the first phases, each phase it's have contained data collections between interviews, between case study observations and literature review, then devise the first framework implemented in critical examinations and case study, and then refine it again and implement it in another case study, and so on until the final assessment of the framework. So talking a little bit about the interviews, different interviews has been done with the different stakeholders that involve in decision-making, such as we are talking about healthcare architect designer, we are talking about biomedical planner, we are talking about facility managers, and we are talking about microorganisms specialists. So these different interviews lead us to different data and descriptions of this process, which is done by each of them about the selecting of hygienic materials. So this data has been transcribed, coded, and then analysis this data to lead us about and to prove the current situations and the current issue. Another things has been integrated in the interviews, the semi-structured interviews actually, a scaling questioning that reflect the scaling questionings by asked to give a scale and why, and reflect this answer in their process that they already described it in the selections and decision-making process they are already made. So later on, that's give us a different themes during the structure of the interviews, which is going between infection control, influence of the material, the influence of the standard, and the decision-making process, which is we can see here, or as an overview, different indications from different stakeholders about the importance of the hygienic material, about if there is already a method they are followed in the selecting of this material, about if there is any influences factor that interfere when we are doing the decision makings. These fluctuations give us the, let's say, the ensure there is a problems going there, and then going back to the interview, semi-structured interview, and do more analysis with reflecting this data in a different process that described from different stakeholders, which is indicate there is a lot of areas they are mentioning they are need more modifications. Reflect these areas and do algorithms about the repeat problems mentioned from different stakeholders that lead us to some outputs from these different stakeholders, whereas most of them, they admit there is insufficient time during the decision-making process. There is a problem with the access to the knowledge and update the data during the process of the decision-making. There is also a problems with update, simplify, and change the standards and norms to admit the new technology. And there is also an influence in decision-making by prioritizing another factor such as cost and so on. So that's lead also. That's
So I'm sorry to interrupt you, but you're going over the time quite a lot.
Okay. All right.
If you can just wrap up very quickly within 10 seconds. Thank you very much.
Okay, so different frameworks has been done, implemented. Just as my final slide. So different frameworks we had be modified, implemented, and now it's keep going in validations and more modifications and assessment for the final result. And there's a different criteria implement when we are applying the framework to occur that framework. The result is valid. Thank you very much.
Thank you very much. A very, very thorough research. And I would invite you to stay there, and maybe there will be questions that will be asked in written to you in the chat, because, yeah, we don't have time before the next keynote speaker, who is Laura Florez-Perez, and she will be talking about AI-driven applications in the built environment. So let's see how the discussions on this important topic will go ahead. Laura, I would invite you to take the floor and to share your slides. And thank you very much, Mouhand.
Hi, Ivan. Can you hear me okay?
We can see you and hear you, and
Great.
we are not seeing the slides for now.
Can you see them now?
Yes, and hit the slideshow, please.
Mm-hmm.
Okay, wonderful. And you have half an hour. Thank you
Great.
very much.
Thank you. And thank you for the invitation. So my name is Laura Florez-Perez, and I'm an associate professor at UCL in the Bartlett School of Sustainable Construction. And I'll share with you some of my views around AI-driven applications in the built environment. So just a brief intro, the place where I come from. So I come from UCL. It is university in London, multidisciplinary university, and it was founded in 1826. It has about 30 Nobel laureates, and it is the second largest university in the UK by enrollment and the largest by postgraduate enrollment. And we're a faculty and staff of many different countries, programs, and faculties as well. We have 11 faculties. And here you might recognize some of our alumni and also staff that have been somehow linked to the university. So you might recognize there Mahatma Gandhi. He was an alumni, and also you can see there Francis Crick for the DNA, and musician Chris Martin from Coldplay, and Alexander Graham Bell, and some others. So let's start with AI, and what do we understand by AI, or artificial intelligence? This is a definition that I obtained from IBM, and it is a technology that enables machines and computers to simulate human intelligence and problem-solving capabilities to perform complex tasks. So basically, computers and technologies are somehow doing and performing some of the tasks that people do. And I put this graph, as you see on the right, as an example of one of the applications that AI, for instance, could do. So we could, for instance, put these characters, Disney characters, in the computer and just ask the computer, just categorize them, right? Put some categorical understanding or meaning and put them in groups. So one of the options and one of the results could be the computer might say, okay, like which characters belong to the same cartoon. So it will categorize, for instance, Donald, Duck, Daisy, and the duck in one group because they belong to the same category. Mickey Mouse is just by itself, and then Bugs Bunny is another character by itself. Okay, we might ask the computer, even the computer might categorize them by whether they have a hat or not, right? It could be another way through an algorithm, and it might say someone has a hat and someone doesn't have a hat, and then it might categorize them like that. So people, we are able to either provide what are the categories that we want and put in the computer what description or what categories we're looking for, or somehow the algorithm might just define what category makes sense. Okay, so this is one of application, doing a categorical description of characters. Okay, we can also use AI for different purposes. So for description, so descriptive statistics, for predictions as well. So many different applications around AI. And the idea is that we use computers to simulate actions that people do. So these are different applications, as you see here, around AI. And why is it so important, and how is it useful? Okay, so we could use AI to have high predictability. So we can use it to look at past data and better predict what's going to happen in the future. So with this, we might reduce risks and just state, okay, this is what happened, and we're able to better predict what's going to happen in the future. With pattern recognition as well, computers can be trained to define patterns and recognize different patterns and structures that we tell them what specifically we're looking at. Generative design, also looking at 3D models and BIM models as well, and looking at clashes, looking at what works, what doesn't work from training that model. Can also be used for digital manufacturing. So we can train that those models to recognize patterns and to then, through a digital model, specify and define some key parts of our infrastructure and our buildings. We can optimize performance as well. AI can be used to define energy consumption and to better optimize energy consumption in a building, or indoor air quality, also inspection. Off-site construction, we can also do this by defining in the model parts and building them from that digital characterization of the infrastructure and the building. And we can also use it for safe monitoring. For instance, we can have drones and we could have different equipment to look at the site and to see potential accidents and potential safety hazards. So as you see, different applications and different benefits if we use AI in the built environment. So AI in a broader sense, and I'm here just showing a very general illustration. Basically, it works as it has an input layer. So we have some inputs, some data, some information that we put into our models or our algorithms. Then we have a hidden layer, and this hidden layer, the fantasy of this is that, well, it's hidden, so we don't understand what's going on. But the idea is that in this hidden layer, basically, we're trying to define what are the inputs and how do they link to each other? What is the relationship between different inputs and also the extent of the relationship? And then we have an output layer, which is the result after all of these analysis from the hidden layers. And I put here as an example, for instance, if we're thinking about predicting productivity or looking at performance, lean performance, we might see that that's the output and how does the input affects that, and we can perhaps predict the output with those links that we understand from the models. Okay. So the beauty about this is that the models look at complex relationships that we as humans might not be able to comprehend, might not be able to see the different links and patterns, and the computer does because it's very powerful. So we look at all of these patterns to understand the relationships. Why do we use AI basically in the built environment? We use it to make decisions based on data, right? We use data to inform our decisions rather than just take decisions out of the blue or take decisions out of a gut feeling. I'm sorry, So we use that to take better decisions. These decisions also help us to take better interventions that help projects to perform much better and to realize their full potential. And at the end, we're taking better decisions because we understand what happened, we understand data, and we can then fully take that information, extract that information, and use it for our decisions. So benefits, there are numerous benefits. We can save on costs and achieve more for less. Also, because we are using past information, we can be more confident about time and about completion time in projects. So we can save on time. Also, we can foster collaboration. And one is the lean thinking about collaboration, how we can bring in different people with different opinions and different perspective to develop these workers and also ensure that the culture is healthy and safe. And then we can boost productivity and efficiency as well. We can take all of these information to then define and predict what is going to happen and how will it impact efficiency and productivity as well. So we have different AI models, and here I show you some examples of some models that I've used. And as you see there, AI could be used as description, like I mentioned before. So descriptive models, you use data analytics to understand real practices and to define relationship between inputs and outputs. We have prediction models, which are the ones that we can simulate what's going on in a specific scenario. We can see workflow or order of activities and links and predict, for instance, one of the things we can predict how many people do we need in a project. We have prescriptive models. These models are mostly based around optimization and linear programming. And we can use those tools to then understand and define characteristics of labor and how to better, for instance, allocate labor on a site with that specific model. And then we have a reporting module, which can take us to usage of resources, what are different strategies, for instance, for labor, and we can have different tools, Gantt charts, to understand what is the consumption around different resources. So here I showed you some examples around AI in productivity improvement, and we look at labor management. And I like to use this example because it's one of the decisions that foremen and project managers on site face. So if you have a pool of workers, as you see there on the left, you have different workers, and the decision is how do they group them in teams? Do they put worker 1 and 2 in one team? Do they put worker 2 and 3 in another team, and so forth? So what is the rationale behind putting them in teams? And once you put them in teams, then there's another decision that comes, which tasks should they be doing? Team 1 should be doing task 1 or task 2, and know that task 1 and task 2 might have different characteristics and requirements. And then the idea, if you're thinking about productivity, is how do we maximize productivity with all of these decisions around who goes where and what task are they doing? So one of the models that I've worked with is looking at how do we predict labor, okay? So if we have different tasks and we have the information of which workers were working in which week and which tasks were they performing, then we can use this information to then forecast and have a better idea of how many workers we might need in the future. And we can use this also to plan for training skills for the workers. And perhaps one of the applications that we've looked at is to identify cases for multi-skilling. So people that might be able to perform different jobs, you can also predict that and then use them longer on a project. Another application is intelligent allocation. And we can think again about the same problem. It's the workers, the teams, and then which task would they go to? So with this intelligent allocation, then you can start thinking about, let's determine the right team for the right tasks. So who goes where? You can look at trade-off analysis. So what will be the implications for the cost if we look at different teams? What will be the implications in time if we use different teams? We might also look at alternative configuration of teams. So if we change teams and we change people, what will happen? And we might also be able to determine patterns of labor. So which worker is working where and what amount of work they're doing. Another application is efficient teams, and this is more descriptive. So we may have, let's say, workers that have worked previously, and we may have a history of how much did they produce, which team were they working, and looking at, for instance, one application is, does personality affect their productivity? So this is based on past experience, and we might determine what is the personality of each worker and whether it affects their productivity. So what workers' characteristics affect productivity, and we might be able to determine what's the best configuration of the teams and what's the best strategy to form then productive teams. And then looking at more advanced AI, so looking at different algorithms and models, we can also have an application here around, let's try to define external conditions. How do they affect also site conditions, or in this case, complexity of the tasks, and how does the labor, if we look at labor of the teams, what is the size of the teams, the age of the workers, the skills, and even the personality, how does all of these link to each other and are affected by different allocation, and then how do we define novel methods and factors that affect productivity and to allocate people as well. So this is an example, and I'm not going to go into detail about it, but you see here different applications of models, and what we're looking here is to how accurate they can classify different people and how accurate they are into making that classification. And one of the results that we use in that specific research I'm telling you is then AI mixed with statistics. We can have results like this that were very meaningful into understanding more deeply around those links. So for instance, one of the results that we found is that teams that are larger tend to be less productive. So somehow there's something that is making larger teams less productive than smaller teams, which requires further investigation. And another result that we got that was interesting from, again, combining the AI with statistics is that in easy tasks, it seems that personality of people has a very big role in defining what is, how do they work, and they're more productive. But in more complex tasks, it seems that the personality affects negatively. So in these tasks is more the capability of the workers rather than the personality. So factors that we can start thinking about for arranging teams and putting people together. So how AI supports lean and vice versa when you start thinking about this. And I put here a slide around, let's think about, well, we have input, right? We have data that we have from the past, so historical data. So what happened there? Then we can do some analysis, understanding, and forecasting. So we might design models, what seems to be happening, understanding that, understanding patterns, what is really happening from those models, and then forecasting, so populated different scenarios, what might happen in the future. And with all of this, then we go to the output so we can use knowledge and understand what has to be done in the future, what needs to be done to be able to use that data. And then in the decision-making process, then we can action a plan, better ways of doing things. So we can think about this as I put here a definition of future or foresight to thinking about what works from the input to the output. And this is a way of thinking about lean as well. We're thinking about how we can minimize waste, how we can maximize value, and all of this will support that. So as you see there, there's a link between AI and lean. We can think about also the two pillars of lean, right? Continuous improvement. We're always thinking about how do we improve things and make things better, and the respect for people. So continuous improvement, we're thinking about, well, AI can process very large amounts of data. We can make decisions based on this data, and then based on that, we can take better decisions and perhaps better ways of doing things. And we can then focus, instead of the analysis on the data, we can then use people's creativity to problem solve. On the other way, respect for people, well, we can just trust that AI will do the thinking and will do the process. And then people, we can use that on the project to have more time to connect, more time to build relationships, collaboration, and to better manage resources, right? So we're leaving the information, the automation technology to AI, which helps support, and we're actually using all the strengths of people. Computers don't have that creativity, don't have tactical experience, don't have that human understanding of how we work. So they can be supported and vice versa. And we can think about that project success as, well, we can use last planner system, for instance, or just in time to then commercialize that. So this is a graph that I wanted to share, and we can think about AI and how it supports digital innovation. And this pretty much ties into what we're thinking about lean as well. It's all of this will help us to minimize waste, to maximize value. So when thinking about development and procurement, and you see that manufacturing components, product development, supply chain as well, assembly and final product, we see that all of these are supported by different activities and different versions and links. So we can analyze what are the requirements of our project, have that skilled labor to support that, have that digital collaboration, digital models and standards that will help to then process and manage information. And we have all of these digital models, as you see there, can also support offsite manufacturing and minimize some of the time. And then we can have in the supply chain that logistics and some of the shared data. So we have all of these links between them to then have a better infrastructure project, a more standardized, consolidated, and integrated system that somehow looks into what we're looking for to maximize the value and minimize the waste. So I just wanted to finish with this slide and thinking about the future and AI. And this is an image that I put there. The reference is not my image, but thinking about how can we use AI and how can we understand AI. And here, as you see there, is an image of Chihuahua dogs and blueberry muffins, okay? So we can train a computer, for instance, to describe and categorize what is a blueberry muffin and what is a Chihuahua. Some models might do it, some models cannot do it. Or some models, for instance, might determine that, yeah, it is a Chihuahua or it is a blueberry muffin, but could not determine whether is it a blueberry muffin or is it a cake or is it a biscuit, okay? So models need a lot of training and they need a lot of information to be able to optimally do that, let's say, that categorization. But we as humans, like I mentioned before, we could do that to a certain extent. So I think that we can use technology to support our activities. We can use technology to help us, but also combining our own judgment and our own creativity and our own analysis and knowledge that computers might not have. So we can use the technology and the computers responsibly, I will say, and in an ethical way. And I don't think that technology will replace some of the characteristics that we have as humans. So thank you very much.
Thank you so much. Thank you very much, Dr. Florez-Perez. I must admit that from the first view at your last slide, I saw only the muffins. Maybe it's because it's just before lunchtime here. But anyways, a very interesting presentation, and we have time to ask several questions. Yes, Suha, go ahead.
Hi, it's not a question, it's more like a comment. I think Dr. Farook has opened the discussion about the role of human by using technology and vice versa. And I think your presentation is like open the answer to the whole discussion that we made. And it's really interesting as a point of view that yes, the technology is here, but it's here to help us. It's like a support, and the human, the role is so important to take the decision and our understanding, our mental model, or that is very important, but technology is here just as a support. Thank you.
Thank you. And Dominique?
Sorry for annoying.
Fine.
Good morning, I'm Dominic. So on the topic of the reduction in productivity in groupthink, have you looked into the research? I mean, it dates back to the 1930s and the beginning of the labor relation movement. But have you looked at the research that was conducted by Elton Mayo at Harvard at the Hawthorne factory? Because they looked at worker motivation. And there's a tremendous amount of good outcome that came out of this work around motivation, around groupthink, and around how in social settings the workers set a norm amongst themselves for their productive work. And the other piece is that's more a question is how do you account for tacit knowledge and personal conditions in the day-to-day of work in your optimization model using artificial intelligence?
Okay, thank you. Yeah, I'll start with the second question. So the tacit knowledge, and I suppose it's interesting to think about. For instance, one of the factors that we considered was the complexity of the task, okay? And this study basically started with that tacit knowledge of project managers are convinced that people that get along well are more productive. In the complexity of the task as well, they somehow, and I was amazed about, they carry notebooks and they had like a scoring system of who is better at which task, the complexity, depending on the complexity of the task. So that's where I come from. That tacit knowledge was so important and so relevant in this study because somehow that started to show that different characteristics, and we can categorize some things that these project managers were doing as tacit to then somehow in our models incorporate that and put it together to then try to quantify that and understand what's going on and to be able to somehow simulate that tacit knowledge. So very relevant in this case, like I said, the tacit knowledge, and that's where it's coming from. And your second point, yes, I mean, I'm not extensively familiar with the study around motivation, but I've seen, I've seen some studies around motivation. And yeah, I suppose it's from a more psychological point of view, which might affect somehow the motivation. With this, the personality was more around that people, somehow we can categorize them in different personality aspects, and then started thinking and started looking at whether how personalities merge and perhaps or complement or work together. So yeah, motivation, like you said, very important. I think is very relevant as well, to see these group dynamics. But like I said, I'm not an expert on. I've seen the studies. I'm not an expert on motivation. But thanks for pointing that out.
Thank you. Other questions? Anybody online? No question for Laura? Okay, so I thank you very, very, very much. It's really very interesting research and inspiring. And I hope you'll be around also for the last hour of our workshop here. It will be a bit late in UK if you're in UK right now, but it will be at 4 o'clock Montreal time. So it will be interesting to have you for the discussion and for the co-creation, probably around all these questions that are arising by the questions and by the discussions now. Thank you. There is a question? Okay, it's an announcement, unfortunately not for you, Laura. We have the lunch served here outside of the hall, so everybody is invited to go out and serve yourself. And thank you again.
Thank you.
Hi. Hello, can I just check that you can hear me, Ivanka? Ivanka, can you hear me?
Yes, I was looking for the mic. Yes, I can hear you very well, Patricia.
Okay, just checking.
Yeah, because you're the next keynote. Yes,
Exactly. Just
in
wanted
an
to
hour.
ensure. Yeah,
Yeah.
okay, perfect. Enjoy your lunch and I'll see you later.
Very nice, thank you.
Bye, bye.
In a minute or two.
You hear us visible.
Maybe you can go get everybody who is outside, please. Thank you. Okay, Everybody's coming back after the lunch, Patricia.
That's great, thank you. I hope it's all going well, and I am so sorry I couldn't be there. I really apologize. I'm really feeling that I'm not there. You know, I really wish I could be there. But yeah.
Well, maybe next time.
Next time, exactly. Yeah.
Okay, so I'll let you share your presentation.
Okay, let me share this.
And so we're starting the second half of our workshop with the presentation of a keynote speaker, who is also one of the founders of this workshop, Patricia Tzortzopoulos. And she will be speaking on user-valued innovations for social housing, and more specifically on upgrading through transatlantic living labs. Wow. We are eager to hear your speech, Patricia. Thank you very much for being with us.
Thank you. No, thank you, Ivanka. Thank you so much. I'd like to start by thanking everybody, and thank you, Ivanka, specifically, and Daniel as well, for organizing the workshop this year. And as I was saying beforehand, I'm really sorry I'm not able to be there with you physically, but hopefully next time I'll be able to join you all. So it's a pleasure for me to be here. So my name is Patricia Tzortzopoulos. I am a professor of integrated design, and I'm currently the head of Department for Design and Built Environment at the School of Arts and Humanities at the University of Huddersfield. So as Ivanka also mentioned, I've been involved in the organization of this workshop since their inception, really. And it's a pleasure. It's a great pleasure to be here and to see that it keeps on going after now 11 years. So it's great to see you all. Today I'm going to talk about a research project that was done in collaboration with Unicamp in Brazil, the Helmholtz Center for Environmental Research in Netherlands, TU Delft in Germany, TU Delft in the Netherlands, and ourselves in the University of Huddersfield in the UK. The project was funded by what is called the Transatlantic Partnership for Innovation in Social Sciences. And the focus of the project was around actually social housing, and more specifically upgrading or retrofitting social housing. And I thought it would be important to come and share some of the results of that project with you, because I think it brings together quite nicely this issue of lean, but also building information modeling and using digital technologies to help support a social issue, which is really around the improvement of identifying user values on the improvement of social housing across the globe, so in different parts of the world. So before I talk about the project specifically, I just wanted to tell you about the University of Huddersfield. So apologies for that. So Huddersfield is a university in the north of the UK. So you can see there in the map where you're located. And you see here some slides with some nice pictures of our campus, and also some of the surrounding areas around the campus. So it's a really, really nice location. The university has around 23,000 students and 5 different schools. So we are one of the 5 schools. And also, as part of my roles in the university, I also established a research center that has been running now for just over 10 years, which is the Innovative Design Lab. And within the Innovative Design Lab, we have 3 different areas of research that we develop as a team. So the first area, which is one of the main areas, is around lean construction, and that involves a number of different projects around theory building, but also construction planning and control, mass customization, visual management, etc. The second thematic area of our research center is around digital technologies, so the use of Lean and BIM. We've done a piece of research around automated compliance checking for design, according to check if they are according to rules and regulations. We've done past work in retrofit and also, of course, the existing work that from the UVital research project, which I'm going to talk to you about in a minute, and also some work around the use of virtual reality for different purposes. And the third area of research we have across the center is around healthcare design. And that includes design of built environments, so the healing built environment kind of areas, but also the design of products, which is basically healthcare products, which is an area of expertise of one of my colleagues within the center. So going back to UVital, so user value innovations in social housing, upgrading, and retrofit. So the main goals for social housing upgrading is really around this idea of course, improving quality of life for populations which are less wealthy, right? But there are a number of issues around helping mitigate social costs that can happen in social housing areas, right, which are problematic. And the costs of those social costs can be quite large. Their costs for the society overall, their costs for employers, their costs in terms of mental health for populations, etc. So the ideas for upgrading is to help mitigate some of those issues, reduce conflicts within areas, right? And also, and one of the main things that have been pushing this idea of the need for actually retrofitting or upgrading social housing is the negative effects that is got in terms of climate change and carbon emissions. Of course, in Europe and the same, of course, in North America and Canada, is the need, there's a huge need for actually heating houses, and that consumes a lot of energy. And a lot of the existing social homes, specifically across the UK and in other parts of the globe, they don't perform very well in terms of energy efficiency, so they lose a lot of heat. So a lot of the push from different governments has been to try and improve those houses to improve energy efficiency, and with that also, of course, help reduce fuel poverty, which has been a problem in the UK and elsewhere. So the main thrust is to try and improve housing conditions, but also, whilst doing that, it is believed that it's quite important that we actually help deliver social values, deliver values for those populations, so improve the way in which they perceive their housing and they perceive their neighborhoods, and also help ensure that those needs are actually addressed in whichever retrofit is being developed. Also, the whole idea, this also provides an opportunity, especially in environments where we have housing associations or local councils actually supporting the delivery and the upgrade of those facilities, of those social houses, to help increase. It's an opportunity, it's seen as an opportunity to help increase learning and help achieve some consensus in terms of the decisions that are made. So things are not just imposed to social housing users, but they actually become more part of the process, right? And we use this, all these contextual issues as an opportunity for us to also evaluate how this concept of living lab could be applied within social housing retrofit context. And I'm going to talk about what the living lab is in a minute. And we also use this in the project as a means to actually test what we call boundary objects. So we use different tools as boundary objects to try and help achieve consensus, to try and help break barriers and achieve some level of shared understanding between the different stakeholders involved in the process of social housing retrofits. And one of the outcomes of our project was the creation of this upgrading process protocol, right? So the issues around the research is really the main drivers is this number of social changes, societal changes which are happening nowadays. So more people working at home. What does that mean in terms of how houses need to be designed and how we need to be retrofitting houses, social houses specifically? The issues of climate change and the costs of actually the environmental costs of having houses which aren't energy efficient, and also the social costs in terms of fuel poverty, as I was mentioning. And also we know that there are issues with the housing conditions in social housing. There's a lot of inadequate housing, social housing in many parts of the world, right? And we also started off from some base conditions. So the idea of the importance of actually ensuring that when we do those retrofits, we help use those as opportunities to help create a more of a community spirit, so people can live together better, you know, and help each other. Also as a way to manage stakeholders' expectations, and we realize that expectations of different stakeholders can be very, very different in the process. And also, of course, improve the physical attributes of the homes, as I was mentioning before. So to start us off, what we've done is we developed this conceptual framework, which describes some of the issues I was just mentioning to you. So it is all about trying to mitigate climate change and help reduce the negative impacts of the built environment or social housing specifically in terms of climate change, but also try to reduce the social costs through improving health and improving quality of life of those populations, right? So some local conditions, of course, need to be evaluated, and especially in our case, because we were doing case studies in 4 different countries in very, very different places, right? So we needed to understand the communities and how they operated within each one of our case studies. We needed to understand stakeholder expectations in the process of retrofitting or upgrading those houses. And of course, the physical attributes, which are very different, especially when you're comparing social housing in the UK with social housing in Brazil, for instance, right? Our goals was to basically deliver user values and also increase learning, create means to achieve consensus and mitigate those social costs and conflicts, as I say. And the approach we used was the Living Lab, right? And the Living Lab was defined within the context of our project, because Living Lab is a concept that is quite broad, and different researchers have used the concept of Living Lab in very different ways. But what we did is we looked at it from the perspective of, okay, well, we'll use it as a process to help us identify user values, right? And facilitate engagement, enable a certain level of co-creation and co-joint decision-making in the decisions around social housing retrofit, and also provide informed feedback for all stakeholders. And we used a number of tools to enable us to do that. So those activities and the tools serve the purpose also of creating some common ground and trust across the different stakeholders. And I'll mention what those tools are in a minute. I'm going to try and play a video that we created as part of the project, because as I say, we had a number of collaborators. I hope it will work. You let me know if you can hear it. Can you hear it okay there?
A cerca de 15 quilômetros do centro de Campinas, os moradores do residencial Quilombo 2 vivem uma vida simples, mais feliz.
Yeah.
Com algumas mudanças,
Yes, we hear.
Perfect, thank you.
Poderia ficar melhor. Para tornar o Quilombo 2 um lar mais confortável, estudantes de arquitetura e urbanismo da Unicamp participam do projeto Will Vital. Ele gostaria que as pessoas mesmo recebem as oportunidades e produzem melhorias. Em visitas ao bairro, a equipe conversa com os moradores e realiza jogos e atividades para que eles apontem as melhorias que o local precisa. A partir desse contato, os estudantes podem propor as melhorias. Um concurso foi realizado e ideias como hortas e composteiras, um parquinho para as crianças e um centro de convivência foram elaborados. Tudo para que eles se sintam mais integrados ao bairro. O projeto continua em desenvolvimento. Estão previstas ainda uma etapa de co-design de propostas e a avaliação dos resultados.
The focus of the German New Vital case study within a social housing estate is on a refurbishment project of 4 9-story buildings. The majority of the residents are elderly people with low income living alone in a 1- or 2-room apartment. In order to gain insights into the process of social housing upgrading and user involvement, interviews were conducted with different stakeholders, representatives from the housing company, the construction planning, the construction companies, including the workers and the residents. During the upgrading process, the residents remain in their dwellings. The major annoyance for them is the disruption caused by dirt and noise from the construction work. We soon realized that in this particular case, resident participation in housing upgrading was limited. As a result, the focus of the project shifted to the green spaces between the buildings. Here, virtual reality is used to show and discuss different design options.
The main aim of this project is to try and understand how useful the concept of a living lab is to define and tease out user values and user needs in the context of retrofitting social houses.
We have been looking into how to use different tools as part of our Living Lab workshops to better elicit and capture user requirements and values.
I'm using 3 different tools. One is the building information modeling, and Farook cards, and obviously the interview protocols.
Our VR cave help different stakeholders to become immersed and to actually understand and improve their awareness of the project, collaborating towards a shared understanding. We have actually created 3 different being models, one for the houses as they are, one for the houses as they will be, and one model which is specific around the construction stage.
We've developed the value card.
So this tool would help us to understand the different preferences of the users.
At the end of the project, we want to be able to have a protocol that is generic enough, but that also actually takes into consideration contextual issues, which will be influencing whatever retrofit is happening in different locations.
In the northeast of the Netherlands, the apartments of Straat Barley are due to be renovated. TU Delft, together with Acanthus and Vectros, uses interviews and VR to communicate the values of different stakeholders to each other. In the first living lab, residents were able to choose the tiling for their new bathrooms and kitchen, establishing their commitment. At the start of the renovation, our VR will present the hindrances residents will face so that they can prepare accordingly. The next phase is to redesign the communal garden using an adapted value card system, our Garden Tinder. Residents will be invited to a collaborative VR co-design workshop. Finally, the residents will choose one of 3 designs, which will be realized with finances from Acanthus, reserved for communal growth.
Okay, so I think this now, the video, sorry, let me just change the slide. So the video demonstrates the different case studies that we've conducted, and also, of course, you could see some examples of some of the tools we use to try and reach some level of co-design and also shared understanding between stakeholders. So this graph here represents the kind of approach we took in terms of the living labs themselves. So what we call the living lab is basically a set of workshops that we developed, right, in which we have a live project, of course, the retrofit of the social housing estate that was going on. And we were bringing together different actors within these workshop settings, which involved local government and those involved actually in providing and social housing, and so in providing the retrofit of the social housing as well. Also, there is in the UK specifically, there is a person that there's a role of a retrofit coordinator, which is someone that has to be involved in coordinating retrofits within social housing. They work normally either for housing associations or for the councils themselves, or local councils. We try to invite architects as well to be part of the process. Unfortunately, in the UK, we weren't able to do that. Ourselves as research and knowledge-based institutes, and also the social housing users themselves. And the idea of bringing everyone together is to enable these conversations to happen, to enable people to understand what's being proposed, understand different design alternatives, understand the different types of disturbances they will have during the retrofit process. So basically, those are the stages that we use. So we had an analysis stage, an innovation or co-creation stage, and an evaluation stage across the different living labs, across the different countries that are used. And what if identified that the living labs are actually across the different countries, they work as a very, very good tools to help find some common ground, to help achieve a better level of understanding, especially not only for the social housing users in terms of what would happen to their houses and what the final result would be, but also for the providers and for the council in our case in the UK, because basically they could understand better what was important for users or not, and the tools actually helped with that. So that was the timeline of the project. So it started in 2020 and it ended in 23, right? And along the way, you used a number of tools, as I mentioned. So we've done there has been surveys of conditions in the local areas. There had been interviews, a number of interviews. We developed value cards, which we use to try and identify what users value more in terms of some general characteristics across the social housing. We used virtual reality, as you've seen in the video, but also build information models as a means to visualize design alternatives, right? We had the workshops around issues which were outside the houses themselves, like, for instance, definition of solid waste areas and stuff like that. And we also use design charrettes and co-design in community events to try and help bring people together. So in terms of some of the individual results, the cases were very, very different as you would expect, right? And funnily enough, some of the results actually are convergent, which is an interesting result of the project. So in Brazil, basically, there is no mandated upgrading, and the users are basically homeowners, which made the process a little bit more difficult because nobody really was responsible for improving the houses, and the owners themselves, of course, they have limited resources to look at develop those improvements, right? There has been, in terms of the living labs and co-design activities that were developed, they have been very positive, and they had a very positive response in terms of the interactions, because it made people think about what they could do to improve their local areas. And they engaged with each other as well, because there was some issues in between neighbors not liking each other very much. So those were kind of resolved as well there. In Brazil, I think it was realized that it would be important. It was quite important to involve children in different types of activities to help engage the users overall, right? And ludic activities as well as focus groups were used, right? A design charrette was done. Initially, they looked into what could be changed in the local area, and that has been a very positive co-design activity. No actual improvements were done in terms of the physical houses themselves. However, I think there were some positive results there. In Germany, as you said, as you saw, the cases were very, very different. This is basically high-rise buildings, right? So not houses at all. The research team has been engaged with that housing estate for many years, because they've been doing long-term kind of surveys. So they have the report with the users already. And the users now are mostly elderly and frail pensioners. So it was a problem, really. The design and the construction process was a big, big problem for them, right? And there has a lot and it generated a lot of conflicts, right? I think, and this is why I think they've moved away a little in Germany from the retrofit of the housing themselves to actually improving the more communal areas, because then it was easier to actually bring together to do that, right? And some ideas were done in terms of what could be done to improve those green areas around the social houses, like having chalk benches, because people felt, because they're elderly, most of them live alone, so they felt it would possibly be good to help increase social cohesion and provide people with an opportunity to have a chat with others. In the Netherlands, the housing estate was basically, the users were very much elderly, and they were immigrants, and there was a lot of issues in terms of the housing association and communicating with the users because of language barriers, for instance, right? During the construction process, because there was a big part of the retrofit was actually internal to the house, not so much external. So users had to leave their houses, and that created, again, a lot of issues with mistrust and people thinking that their houses would be, you know, there will be issues in the houses, and when they could come back to the houses, things wouldn't be the same way as they were before. So the VR was used in the case study to actually help reduce fear from the users and also increase the user's voice in terms of the decision making. So they could choose, for instance, styles, colors, and things like that, and that was perceived as very, very positive. But again, in the Netherlands, a lot of the focus ended up being around the outside areas, the communal areas. So in terms of what could be done to actually improve the community, the close neighborhood of the community overall. In the UK, basically our case study was focusing on a set of 8 houses which were retrofitted, and you can see a picture of the end result here on the slides, right? What we've done in the UK was to use our living labs to bring people together, and we use the different tools, right? So we use the building information modeling, so we're showing videos of the during, the before, the after, and the during construction as well, what it would look like. And we also use the 3-sided VR cave to try and see if users would feel comfortable in getting immersed into the models. And funnily enough, the users didn't really like the 3-sided cave at all. It was difficult for them. They didn't feel comfortable, and they preferred to see the models. And also to use the physical value cards, which were really well received, right? Again, funnily enough, a lot of the discussion ended up being around the outside areas. So how would the fences be? Where would the waste bin be located? Issues like that, which are, again, going back to this idea of what the environment, the immediate house environment looks like, right? And not so much about, of course, the choice of colors and so on was also part of it, but there was a lot of issues around the local environment. And this is just a picture of our BIM models. And this is how, another thing we've done in the UK is we've done a sets of interviews, and we used the laddering technique to create a hierarchical value map of what was more important for the users in the specific retrofit. And that was, again, used by the housing, not the housing association, the council. It was perceived as very positive because there were some issues which came out of those interviews that could be addressed and weren't thought, by the teams actually involved in retrofitting the house. And these are just, again, some just a couple of pictures of the value cards, and we developed them around those areas that you can see on the slide. So there are some cards around security, privacy, sustainability, environmental quality, the remodeling process themselves, thermal comfort, accessibility, and maintenance. And here is just, again, just to show you what the BIM models look like, so we use 3D rendering. You could see, different times of the dates and different sunlights and so on. So it was the models are quite realistic, and people really liked using them. And these are just a couple of pictures from the usage of the 3D cave. Right. So the value cards really helped in terms of requirements prioritization. They actually trigger new insights, help people think of different things which might be important and how those could be addressed in the retrofit. And so it helped in terms of actually helping new requirements emerged throughout that process, and those requirements could then be considered, as I say, on the retrofit. The real-time rendering was really well received, as I said, and it did enable, I think it was really well perceived, especially not only by the users, but also by the council themselves. And they could see that the optioneering could actually happen in much more well-informed way. So in our case, when we actually developed the models, the design decisions had happened already, so we couldn't influence design so much. But if we would use this in the earlier stages of the project, I think a lot of the stakeholders saw it would have brought a lot of benefits and would have avoided a lot of disruption and discussion with users themselves. And the VR tool, as I say, I think we felt it was beneficial, but if you look into cost value analysis, I think we wouldn't use it again in a new project because it was very difficult to actually develop those models. But at the end of the day, I think the 3D rendering from BIM models work much better in this case. So some common results then, right? So I think we did achieve some common ground. Topic was certainly the semi-public areas, right? The adjacencies of the houses, what happens in green areas which are close to the housing. So that is extremely important when developing social housing retrofits, and it's something that sometimes is not really considered so much, right? I think the Living Labs really enabled this the possibility of actually creating those better links, creating better trust across stakeholders as we thought would happen from the beginning. And the important thing is that it was felt that it was quite a powerful and a good user empowerment as was achieved through this process of engaging with users, looking at alternatives and these mediated discussions, if you like, across the stakeholders. Of course, there are issues, I mean, in terms of the Atlantic divide, you know, with cases in Europe and then in Brazil. Of course, there are a huge number of differences across climate, the focus of upgrading, the processes that are used for upgrading, the partners involved in it, and of course, home ownership as well. However, there are some communalities, right? So the issues around social, environmental, and technical changes which are necessary, and of course, those are similar across the board. The issue that social change actually needs sustaining through this local long-term commitment to improve living conditions. So it's not sufficient to just retrofit the houses and leave users to their own devices. That is important to keep those communications on in between housing providers and users to ensure the community improvement is there on a long-term basis. Empowerment, you know, from the user's perspective in terms of voicing their needs and their desires was really important, and it was important across the board. And of course, the co-design of solutions was perceived as extremely important by everybody involved as well, right? And finally, this is basically our upgrading protocol. So basically, we have the phases of a living lab, what can be done and how it can be done to try and support the retrofitting process. So I'll just skip a couple of slides here, but just to talk about the recommendations of the project finally. So the preparation of upgrading and retrofits in social housing is extremely important. So the more prepared and the more engaged the users are from the initial stages, the better. Also, we realized that there's quite a big need for people to actually understand, especially social housing users, to understand the context for upgrading and upscaling the houses, why things are happening, who's making those decisions, and ensure empowerment, as I mentioned beforehand. It is absolutely essential to be user-centered when we're doing those interventions, to look at sustainability, but also help create resilience and a better environment for communities in social housing areas. Look at green areas, okay, and areas which are outside the houses themselves, because that helps create a better sense of cohesion and create better sense of ownership of the housing, and also better links across the community, which is extremely important. It's really important to prepare users for the inconvenience, for the disruption. For us, it's of course obvious there will be disruption, but people don't really necessarily realize the level of disruption they can have when a retrofit is going on. Make stakeholders aware of the benefits and ensure that you use different tools to help visualize ideas. So models, the VR, BIM, videos, 3D maps, different tools, right? And trigger these questions on climate change and ways of living. So we help people understand as well how can they help themselves, how can they ensure that their houses are more energy efficient, how can they reduce their energy bills in terms of how they use and operate the homes, and so on. and negotiate conflict and mistrust, because in a lot of projects, people tend not to involve users very much because it makes the process longer. It can create mistrust. It can create all sorts of issues. You know, it tends to increase cost. But there is a way of actually, by using the approaches we are proposing, I think we can manage those risks and provide better value at the end of the day. Okay, so that was all I had to say. So thank you very much. If you have any questions, I would be really pleased to answer them. I hope I didn't over talk for too long. So thank you. I'll stop sharing the screen now.
Thank you very much, Patricia. Questions? Do we have questions online? I have a question. So in one of your recommendations, you were saying that it's very important to prepare the participants. I'm not sure, I don't think I heard how in these cases you prepared them. Was there any period for preparation? What did you do? How did they accept this preparation?
Yeah, I think the preparation is not to prepare the user so much, as to prepare the process and ensure that we are actually implementing means to actually identify user needs and values at the start of the project, because that normally doesn't happen, you know. Users, when there is engagement, and there is by law in the UK, for instance, there has to be user engagement in the retrofit of homes, of social homes. However, that tends to happen too late in the process. And what we realize is that councils, for instance, they tend to just hire architects, develop the proposals, not engage with users, and then show them at the end, right? And what we are trying to do is to ensure that there is within the process means for people to actually get engaged and provide their views and their values from the start. And also by doing that, they can also understand what the level of disruption would be, and then there will be less complaints later on during the process, right? And better trust between stakeholders.
Yeah, I understand. I thought that there was some kind of educational activity almost, because sometimes in architectural environment we'll say we have to teach we have to teach the client, actually, to educate the client so that he can take informed decisions. Because maybe, and in one of your slides you had, they were not aware of modern ways of living or something like that. Yeah. So maybe this kind of education preliminary before they're part of the concept of the design process is necessary, so that
no, absolutely, absolutely. And this is something that the local authorities were really interested in, that because sometimes they install new equipment within the houses, you know, and people don't know how to use them, and they still open windows, and they, for instance, block vents, which are supposed to be there to ensure that there's not too much humidity, you know, within the houses, because they don't understand how those things work. They end up actually doing things which are bad for them, and then they have poorer quality of air, they have more mold in the houses and all that. So as part of these activities, of course, it was an issue of actually showing and demonstrating how this new equipment operates, and how they should be actually using different features of the houses. And also talking about, as I was saying, I mean, how do they ensure they are using the house more as effectively as possible, so they reduce their energy bills, right? This is really important. And sometimes the population don't have access to that information. And by using these tools and being part of those activities, I think that can then be done much more effectively, you know.
Yeah. I don't know if there is another question from the audience. I have many questions. I can continue like that. So what was the most difficult part of this, of the whole research project?
Right, there were a number of different things which are actually difficult. One thing was, I mean, it seems like, it seems obvious that if you invite people to come and participate in those activities, they will come. That's not necessarily the case, right? It was actually quite difficult to bring people onto campus to actually do the Living Lab activities, right? And to see the models and so on. And we had a limited number of people who attended, right? And as I mentioned in the beginning, for instance, the architect He had been paid already. He didn't care. Okay, so he didn't take part, which is a shame.
Yeah.
Right. So this is one of the difficulties, right? The other difficulty was the technology itself. So the VR cave, it was just too complicated. So the simpler the technology, the better. And VR works well in that way because you just put some glasses on and you are kind of interacting with things. So the simpler, the better, really, I think. And then there were also issues from a research perspective in terms of the different people who are involved in developing those case studies in the different countries. We all come from different backgrounds. So myself and Doris, we're coming from an architectural background, but we have Clarine in the Netherlands coming from a psychology background. We had Sigrun in Germany coming from a geography background, right? And sometimes we talk about scenarios, right? And I had an understanding of what a scenario is. Doris had a different understanding, Clarina completely different, and Sigrun even more, right? And the project, of course, also started right when the pandemic hit. So we have had a lot of workshops to try and get some common ground in between ourselves, as well as a research team from the beginning, but we couldn't do that. So it was all virtual, and that complicated things. So all those are learnings. So I think especially when you're doing multidisciplinary research projects, which is more and more important and is what we have to be doing nowadays, to tackle some of those big grand challenges we have at the moment, we need to bear in mind that we need to create some common ground between ourselves as well, I think, as researchers. So
yeah, very, very interesting. And the last question on my side, is there any planned follow-up on how all this worked? Other clients, the people with whom you worked, are they satisfied with what they have now?
Yeah, no, the houses that were retrofitted, the users were really satisfied, And of course, what we have at the moment is ideas for further projects, So we have some proposals outside. One of them is looking into, for instance, using GIS and other tools to help councils actually focus the investment decisions, or support them in terms of how these investment decisions are made, because there's limited amount of funding to retrofit homes and a huge amount of homes that needs to be retrofitted. So this is one of the proposals. The other proposal is to try and identify, for instance, through databases, links in between housing, which has been retrofitted, and effects in terms of health outcomes for the population. So identify if, for instance, in a house that had mold beforehand, if any respiratory issues have been resolved after the retrofit. So identify, if the retrofit is actually helping health or otherwise, because that can be the case as well. So those are two proposals we have at the moment. Let's see if we get the funding, hopefully in a couple of years' time, we can come and talk about the results as well.
Very nice. I have an idea about the proposal. I'll talk to you separately.
Oh, fantastic.
Okay, so another round of applause for Patricia, and thank you very much for helping us organizing this workshop also, Patricia.
Thank you, and once more, I'm sorry I'm not there. I really wanted to be there and visit Montreal. I've never been, so I do hope I'll find
you're always welcome.
Okay, thank you.
Yeah, thanks. And moving on to the next block of presentations, we have 3 more before our next coffee break, but it's a long block of presentations. So we start by Giuliana Baldissera, who will be talking about identifying healthcare built environment and healthcare service attributes towards value generation. Are you there, Julian? Do I pronounce well your name?
Yeah, hi, I'm here. It's Giulie. It was
okay, sorry.
Quite there. It's okay. It's okay.
Okay, so you have the floor. You have 10 minutes, and please share your slides or your.
Okay, I'm going to put my slides here. Just 1 second. Here. You can see my presentation?
Yes, it's perfect.
Yes.
Go ahead.
Okay. Well, I'll try to keep on the 10 minutes, but if I pass it, please let me know, but I'll take care. Okay, well, good afternoon, everyone. My name is Giulie Baldissera, and I'm a PhD student at URGS. My main supervisor is Professor Carlos Torres Formoso, and my co-supervisor is Professor Patricia Tzortzopoulos, who we have just heard. And both of them are taking part of this event. So I'm glad to be sharing here today with you part of my research study, which is entitled Identifying Healthcare Built Environment and Healthcare Service Attributes Towards Value Generation. Okay, so for starters, it is already known in literature that healthcare built environments are recognized as fundamental for healthcare service delivery. However, despite there are several studies addressing design parameters of the built environment, attributes that explore the interconnection with services remain unstudied. I guess it is important to say that in this research, we acknowledge healthcare built environment as a set of interconnected environments and their associated attributes, which are designed to provide a specific service. So it is not only about the physical space, but also several variables such as healthcare, technical, and user-related aspects. And as I was saying, the previous research studies have acknowledged the relationship between the built environment and the services provided with distinct designations according to the research focus. But the common ground between them is that all of them are based on attributes of the built environment in creating services experiences. So, and another thing that we can see is that none of them addresses to value generation. Therefore, we have conducted a literature review aiming to understand these attributes and their connections. So, regarding the literature review, we, according to value generation principles, the understanding of user requirements and their translations into design solutions is important to highlight. And given the interdependency between the healthcare built environment and its services, users commonly rely on physical aspects as evidence to evaluate the service. So the literature approaches that are available between built environment and services, it's atmospherics, servicescape, and housecape. So atmospherics is a tool proposed by Kettler that enlightens the manipulation of the tangible aspects of the facility to stimulate a positive response from the user. Servicescape is an approach that assumes that the physical environment influences users' perception of the service regarding the retail market. And healthscape is an approach that was proposed by Hutton and Richardson that builds upon both of them, atmospherics and servicescape. So it is the perception of the influence caused by physical elements of the healthcare built environment on their users. So the methodological approach adopted is a literature review that began by defining the scope, built environment attributes, and service attributes for healthcare. The starting point was those three research studies, atmospheric, servicescape, and housecape. And also there is a study that was conducted by Han and among other authors in 2018 that was also a useful basis. So between the papers that we have encountered, there were 14 important papers to consider. The identified attributes were 72, but we have done a refinement process in order to avoid redundancy. And finally, we've got 58 attributes that were categorized in 6 dimensions. Here in this table, we can see how we organize this information. In the left, we can see the 6 dimensions, here are 2, and the attribute. And here on the right, we can see the 14 papers, they are listed here. And we can see which attribute appears or is mentioned in each paper. So the columns show if the specific attribute was mentioned or not. Here we can see physical infrastructure. Here we can see functionality, services, social. And here we can see a graphic that shows us how is the recurrence of each dimension that the 14 papers mentioned attributes. And after analyzing it, we can see that environmental conditions and aesthetics were predominant. They are approximately 50% of the papers mentioned them. And in the environmental conditions, in all the researches, the most mentioned attributes were in environmental conditions that were lighting and acoustics. They were mentioned in 13 out of the 14 papers. These attributes are part of the environmental condition, and we can see that this shared predominance in the literature points to the importance that these attributes represent something very important for the user experience, and that they are common to most of the healthcare built environments. And regarding the least mentioned attributes, we can see services. They were mentioned only in a few papers, and this reveals a gap in knowledge that many literature do not consider services itself as part of the influencing attributes. Also, regarding the least mentioned attributes, we have 13 out of the 58 attributes that appeared that were mentioned only once. And it is possible to see that all of these attributes that were mentioned only once, they are very specific, and sometimes they are very specific to a hospital unit or to a hospital service. For example, space for kids that we have here is something that is not applicable to all of the healthcare built environments. For example, in an ICU, it is not a requirement because children do not obligedly have to be there. So therefore, this is a possible reason why these attributes were not covered in some studies. And in conclusion, there is an understanding that the attributes related to the healthcare built environment and its services can provide insights into what can be modified in order to improve value generation. And as this is an ongoing research, this paper provides a starting point on the discussion of attributes from an integrated approach on healthcare, built environment, and services. We may highlight as theoretical contribution the analysis and listing of the main attributes mentioned in previous research studies. And as for the following steps of this research, it includes a discussion on each attribute and the development of a conceptual model to integrate the available knowledge. Also, in parallel, we have been conducting empirical studies. So we have been noticing that some of those concepts that were mentioned before in the literature review are indeed frequently mentioned in the interviews. So the literature review supports these concepts and the definition and our understanding. However, there are some that do not appear in the literature, but are mentioned in the interviews, or vice versa. So we believe that that is due to the context dependency of those attributes, those specific attributes, to the hospital unit or to the hospital service. And that's it. Thank you for your attention.
Thank you. Thank you very much. Questions? Thank you for the wonderful time management also.
Thank you.
Who will be asking the first question of the afternoon session? I have a quick question.
Sure.
Do you think that your research is transferable to another type of buildings? Because I understand
Sure.
that the need is really big in healthcare, but what about universities or, I don't know, other buildings?
Great, that is a great question. Actually, Servicescape, that is one of the approaches that we have been researching, is from the retail market. So there are some researches that focus on another kinds of built environments, but I believe there is not something that gathers all of the attributes. So it would be possible to transfer for another field of knowledge, sure.
Okay. And I don't know at what stage of your PhD completion you are, but what are the next steps? Are you intending to improve some of these? I mean, this is the literature review, obviously. What are your next steps?
So yes, I'm almost finishing it. So there are some steps to be, mainly the writing, but what we have been doing is we had the interviews and we have some hierarchical value maps. So the basis of the hierarchical value maps are the attributes, and we are confronting it with the literature. And that is what we have been seeing, which attributes have a significant impact on value generation and how it is transformed into value generation. So that is the second part of the research. Let's put it like that.
Okay, interesting. Okay, there doesn't seem to be another question. Ah, there is. Take the mic, please.
Thank you. Hi, thank you for the presentation. I would like to know which types of professionals were the focus of your interviews?
Sure. Thank you for the question. We have been using interviews with multi-professionals and with multi-group of users, actually. So there are professionals from the staff, the technical staff, administrative staff, healthcare staff, the clinical. And we also have conducted some interviews with the patients, but those are not so easy since we've had a pandemic scenario in between the interviews. And but we try to cover the front stage users.
Yeah, thank you. Yes, I asked that because when we look at the evidence-based design types of projects, we see a lot that the users are a big part of it, and that's the hospitals actually focus a lot on the users. And so, as I saw you in your presentation, social aspects were like in 80% of the literature review. So I think it's a great point to explore a little bit more this point of view as well, because hospitals are made for patients, in essence. So yeah, that's only the point I was curious about. So thank you.
Great, thank you. Thank you for your consideration. And as a matter of fact, yeah, most of the researches that I have been gathering, they are mainly on the staff, and most of them say that it is very important to ask the final user, the end users, the patients and family. But it is kind of hard, but we are trying to do that. It's a smaller group of users, but we have been interviewing them.
Very well. Any other questions? Okay, thank you then very much. And
thank you.
We're going ahead to the next presenter, Julian Páez-Martínez, who will be talking, I don't know what the whole title is, but it begins by Chronicle of a Disaster. So let's see what this will be. You have the floor, Holmes, Julian.
Thank you, Ivanka.
You
Okay.
have 10 minutes if you want
Okay,
to
thank
have
you.
questions.
Thank you. My name is Julian Páez. I'm a civil hacker. Also, I think I am an outsider here in the link construction field. So today I will discuss how the construction industry can be humanized using a case study. My inspiration for this case comes from the literature, and particularly from a book, a well-known book. Maybe you know this is Gabriel Garcia Marquez, a Nobel Prize winner. This is Chronicle of a Death to Law. So the inspirations come from that this book. So here are three representative images of the case. Hidroituango is one more hydroelectric dam built in Colombia, my country, and particularly crosses the second river most important in my country, that is so-called the Cauca River. So I have an update of my presentation because I took note the Professor Koskela mentioned this morning. That is, good decisions often do not produce good results due to the implementation challenges. And this is evident in this case study. Today, the project is finished and in operation. The link construction philosophy was implemented completely in the conception, design, planning, and the operation. So it's a very, very bizarre contribution because it's a contrast between the link construction implementation in an important project for my country. So the purpose of this presentation is just to shed light of how to improve the link construction field, just making relationships with the social science, and particularly in the political science. So I'm going to present some implications for the link construction in this large infrastructure project. So I like to quote this lean principle that is emphasis on client satisfaction, collaboration, and continuous improvement. But on the other side, in Hidroituango was intended to generate clean energy, huge gold nowadays in Colombia. However, it is become a symbol of political discussion because the disadvantage of the effects or negative effects on the nature. So the project was conceptualized in the 60s, and the construction took place in 2009. And there was major issues between 2018 and 2022. There was a long gestation period. The project, as I mentioned before, was started in the 60s. The construction began decades later. Between those years, there was a huge change in the political and institutional priorities influenced by the project. There are very, very important decision triggers and also in the implementation. So at the end of the day, the political campaign, the economic interest in that implementation between the conceptualization in link construction terms was influenced often by the political arena and the discussion around the institutional logic in the project. At the end of the day, there was a community interest, but this interest frequently sidelined. To analyze what had happened in this implementation of the decision in the words of Lean model, it is important to recognize the politics in those decisions. So one of my main message in this is look to the relationship between issues such as link construction of philosophy in the link construction field with other branch, such as a political science in the decision of large infrastructure projects. There is a good opportunity to promote these new relationships in the literature and the academia among students, also in the PhD students, as I mentioned before. For instance, integrating link with other branches of the social science, the importance of robust risk assessment and proactive stakeholder engagement, also embracing lean and the relationship with BIM principles for more resilient and sustainable project management. At the end of the day, I think there's a huge hole in the lean construction literature regarding the societal intervention in this kind of project. So, in conclusion, there is a necessity of integrated link construction in large projects. Finally, humanizing the construction industry requires a shift towards more inclusive and transparent decision-making process. So, at the end, final thought, by learning from the challenges such either in triangle case study, we can pave the way for a more humanized approach to construction, ensuring that infrastructure projects truly benefit all stakeholders involved, not exclusively the owner, the stakeholder, also the community. So thank you for your time and attention.
And thank you for your presentation. Okay, I'd like a lot to have questions from the public, from people online, or maybe you have questions for us, Julian.
But first, how many people are there?
Well, there are, I don't know, I haven't counted them, around 30 here in presence and about, I don't know, maybe 10, 12 online. It's a workshop. It's not a big happening, but we think that this is better for discussions in a smaller group. So that's why I'm allowing myself to ask the presenter, does he have questions? So it's rare to see lean construction discussed in big civil infrastructure projects. From my industrial experience, this is actually the best place to implement lean construction. Do you have any thoughts about comparing both building construction versus civil projects construction? From the perspective of lean, of course, or implementation of lean.
Yes, I know there's a good and huge implementation in the building sector, but the infrastructure sector is also important, not only because it's a good opportunity to implement, also for the advantage of the effects on the society and the community. So if the lean construction serves as a philosophy of the production change, I think the best way to think about is also in the infrastructure projects such as Idris Vango project, because the history is long. Maybe 10 minutes for the presentation is quite a few minutes for present, and I invite all the person to introduce and in the reading of my research paper.
Yeah, for sure. We'll read your research paper. I have, okay, there is a question.
There's a question in the chat.
Yeah, what was the role of community in this large project?
Yes, it's an excellent question. I've been, as you understood in my presentation, this is a long history, also for 50 decades in my country. The roles of the community changed a lot between those years. But at the end of the day, I think there's a stigmatization of the community. Honestly, the community was taking a part or took a part of the decision, of the central decision of the project. Well, this was misleading and between the decision process and the community.
Okay, that's quite disturbing. Any other questions? Don't see any questions, so we can go towards the next presentation. Thank you again, Julian. And the titles become more and more intriguing. So the next one is the Kirk-Spock leadership paradigm, integrating intuitive and analytical strategies in construction project management. And the presenter will be Ilya Pourahimian. So you have the floor, Ilya.
Hello, thank you so much.
Okay, yeah, we can
Can you hear me? And
yeah.
you have the presentation?
Yes, that's perfect. Go ahead.
Perfect, thank you. So good afternoon. As you mentioned, we have like an interesting topic, and it's totally related to at least two of the keynote speakers from the morning and noon, and it is the Kirk-Spock leadership paradigm, which is the integration of intuitive and analytical strategies in construction project management. We will use two figures from sci-fi movies, which is Star Trek, and we're going to embark on an exciting journey through the cosmos of construction project management. And our guide will be the legendary leadership duo from Star Trek, which is Captain Kirk and Mr. Spock. For those who are not very familiar with these two characters, Kirk and Spock represent two contrasting yet complementary approaches to leadership. And the intuitive risk-taking style of Captain Kirk and the logical, analytical mindset of Mr. Spock. And in the construction project management, these paradigms offer valuable insights by blending Kirk's intuition and adaptability with Spock's methodical analysis. So we can navigate the complexities of project recovery and enhance decision-making processes. I want to mention that this topic is not my major study for my PhD, but in all our discussions with Diana and Dr. Hamzeh, we ended up in something like this, this topic that during our discussions, and we found it particularly inspiring, and we tried to come up with a short paper to see the feedback, and based on that, we will continue working on it as side study. And so let's dive into how these two iconic figures can inspire and inform our strategies in construction project management. So in organizational settings, individuals and groups face various opportunities and restrictions that influence their actions and decisions. The leadership dynamics of Captain Kirk and Commander Spock in Star Trek illustrates this with Kirk's intuitive, decisive leadership and Spock's logical and analytical approach. So Kirk's style demonstrates how intuition and emotional intelligence can enhance organizational commitment and performance, aligning with theories that suggest leadership behavior as essential in fostering organizational outcome. On the other hand, Spock's methodology emphasizes the importance of analytical thought and planning in complex situations and intuition, from natural instincts to expertise gained through experience. And it is vital for decision-making in uncertain scenarios. So experts like Spock use their experience to identify patterns and make quick, intuitive choices when needed. the leadership qualities of Kirk and Spock provides insight into the synergy between intuitive and analytical approaches in organizations and emphasizes the need for flexible and adaptable leadership to achieve optimal results. So in this paper, what we're trying to introduce is the Kirk-Spock leadership framework, which is integrated, and it's called KSLF for construction project management, which is a sector characterized by unpredictability and complex projects. So this model advocates for a leadership style that combines Kirk's intuitive charisma with Spock's analytical rigor. So it caters the unique demand of the construction industry. It aims to enhance team collaboration and project outcome by promoting a leadership approach that balances these two, intuition and analytical thinking. Such a strategy is essential for innovation, resilience, and the successful navigation of challenges in construction projects, which highlights the critical role of adaptability and quick problem solving in achieving project success. So based on the literature also, like the growing interest in integrating of intuitive and analytical leadership styles within organization behavior and management feature the critical examination of decision-making processes. So scholars, like during different years, they did, for example, in one study, they differentiated between the intuitive individuals or teams who tend toward task-oriented actions and their analytical counterparts who engage in social emotional behavior affecting team performances. In another study, Beth and Glockner, they noted that intuition allows for the quick assimilation of information with minimal effort influencing decisions smoothly. And they stress the need for social perceptiveness, behavioral flexibility, and the refinement of intuitive decision making through practice. And in another study, Norton introduces the concept of flexible leadership, highlighting the adaptability role in effective leadership and how context-specific factors shape leaders' decision-making processes and follower satisfaction. So in this study, they establish a critical balance between intuition and analysis for leadership efficiency and adapting to organizational needs. But what is the application of these two approaches in project management? Captain Kirk's intuitive leadership showcases the value of quick, experience-based decision essential for managing uncertainty and tight timelines. And this leadership style marked by flexibility and team morale boosting, characterized effective communication, adaptable team culture, key for navigating the complexity of construction projects successfully. Conversely, the other side of the story is Spock leadership style represent analytical leadership based on fact and figures, prioritizing the logical reasoning, meticulous planning, and data-driven decisions. This approach features the necessity for objective evaluation, comprehensive planning, and detailed control in construction management, ensuring projects adhere to the set standards and objectives. So Spock's methodology focuses on breaking down complex problems and utilizing project management tools for through planning and execution. And it advocates for a systematic, unbiased approach to overcoming the construction project challenges. Integrating Spock's analytical strategies enhances project outcome through greater precision and impartiality, affirming the significance of a balanced, intuitive analytical leadership paradigm in achieving project success. In this paper, we try to employ design science research methodology to develop the Kirk-Spock leadership framework, which is the goal of this paper. for construction project management. And in this context, the problem identified is the need for a leadership approach that effectively integrates both intuitive and analytical decision-making to tackle the complexity and uncertainty of construction project. And the artifact that is developed for this is to address, this problem is the KSLF, which synergizes the intuitive visionary leadership exemplified by Captain Kirk with the logical analytical planning characteristics, and the Commander Spock with the data-driven approaches. However, it is important to note that this paper does not include the empirical evaluation of the KSLF as it is at the early stages of the study. And we're planning to implement it in the real case to see what will be the outcomes. Here, I'm sorry if the figure is a bit big, so the text it's smaller, but I will zoom in and I will show the details in the figure. The KSLF is a comprehensive approach to construction project management that balances intuitive visionary leadership with analytical data-driven. And the framework's purpose is to drive project success through a blend of inspiring directions and meticulous planning. It sets out clear actions, for example, developing and communicating a compelling project vision, integrating advanced data analysis into planning, employing a balanced decision-making matrix that values both data and intuitions, you have data and experts together, and fostering an adaptive project culture through continuous learning and resilience building programs. So I will zoom in this figure and show the the features of this, the characteristics of this framework is the component, and the purposes are the visionary leadership, which our purpose is to drive team motivation and momentum. And the key actions are vision statements, communicate visions, and trust intuition. Analytical and logical planning, which is the other side of the story. Balanced decision-making, which is the combination of these two, and adaptive and resilient project culture. The other characteristics is actionable steps for implementation. We have applications in different contexts for these. For example, the Kirk principle is best fit for crisis management and seizing opportunities. The Spock principle is best fit for risk analysis and processing technical data. And the balanced decision-making is for strategic planning and milestone reviews. And the ease of understanding and user-friendliness of this framework is it's a straightforward language. It should have a straightforward language, visual looks like flowcharts and case studies and examples, onboarding and refresher courses, so to keep the framework alive and continuous development. So for the conclusion, the Kirk-Spock leadership framework for construction project management advocates for a harmonious blend of Captain Kirk's intuitive leadership and Commander Spock's analytical precision. So it is essential to complex nature of construction projects. The framework cautions against an overdependence on artificial intelligence, which might compromise human intuition, empathy, and innovative capacity. So the KSLF aims to foster a technologically proficient and deeply human-centric project management environment that ensures project success and responsiveness to human needs. This is achieved by promoting a balanced use of AI for its efficiency and the unique qualities of human insight for creativity and adaptability. For the future recommendation of the future pathway of this study, we need to explore the role of digital technologies, examine how emerging digital tools can further enhance the balance between intuitive and analytical leadership. And also we need to investigate the impact of AI and machine learning on decision-making processes within the framework. And we also need to develop a training programs, like to design and evaluate training programs aimed at fostering flexible leadership skills that integrates both intuitive and analytical approaches. That's all from me. Thank you so much for listening.
Thank you very much. Questions? Go ahead, Erik.
All right, thank you. I myself am a Star Wars fan, not a Trekkie, so I would have liked to see the analogy with Star Wars, but okay. No, appreciate that. I guess, the management literature is rife with these types of analysis and frameworks of leadership styles and everything. So how much do you take from that literature, and how much do you create a new framework for the construction that's, for the construction industry?
Yeah, as you mentioned, there are so many studies on this, and as I mentioned, like also it is at the early stages of the developing, because my major topic for my PhD thesis is related to developing a new framework for project control. But as we go deeper and deeper, we notice that at the end of the day, you need to decide what's the balance between the technology I will use and what's the balance that I will use the expert opinion. So this is the trigger that leads us to do a study, something like this, to somehow show the need for such a study at the end of the day. We need to identify, in some cases, we need to totally depend on the data, but after a while, the data is not the thing. You can see all the fluctuations, all the deviations, but you need someone to somehow interpret these deviations, why it is happening, what's the reason, what's the root cause of this. So this is kind of the idea behind this study. As you mentioned, we need to study all of those new frameworks and leadership styles, but these two are the most close ones to the project in environment so far. But maybe later on in the future studies, we notice that there are other ways of leadership that can be added for sure, as a new perspective, as a multidimensional perspective of the leadership in the construction environment.
Thank you. Other questions? I have a question, and it's related not only to your presentation, but also to the keynote speech by your supervisor.
Yep.
Not so long ago. So he said that we should try to make machines more humane. And really, exactly one of the two sides of leadership that you are discussing is absent in robotic interventions. So will it be helpful to say that the Dr. Spock's role can be taken by machines, while Chief Kirk's role should stay with humans, at least for now, while the machines are kind of limited? And we don't need to replace all humans by machines, that's for sure, but what do you think? What's your position about that?
Actually, also Dr. Farook is here. He can also answer from his own perspective. But on my side, I can say that, as you mentioned, we can keep AI as a support tool and AI and machine as a supporter to our decisions rather than decision makers. They can be a decision support system, or anything like that. And at the end, they can support the decision that can be made by human. The humans cannot be replaced totally by AI because of the experience factor, the empathy, so many other factors that right now we don't have the technology capable of doing these. And for example, if I give an example from the movie itself, the Mr. Spock is the person that when you give a scenario, it calculates all the possible combinations and says, but with 1%, we can do this and we will be successful. On the other side, the Captain Kirk is like a person who decide, okay, if it is the chance for 1%, we can take the risk and we will be successful. This mentality, we don't have it with the AI or the machines. So they will go with the figures and numbers. It is possible that you end up in a project that the possibility of being successful is like less than 10%, but you will go for it with the human in power. But with the machines, it will stop right away because it is not doable based on the machine logic.
And there is a question by Dr. Forg.
I was also a fan, so and if I recall well, like Spock was not very good taking decision. It was mainly Kirk that was taking decision. Yes. Because one thing that you can see is usually decision has to be made with a wicked problem. You heard about wicked and tame problem. Yes. And Spock is really like the logic is good for tame problem, but most of the issues in project management are wicked. So it's the reason why the balance, I'm not convinced about that. Like it's good for support, for making the decision, but not to make the decision. Because you need that little edge that to find solution about things that are not 100% clear.
Yeah, go ahead. Do you have an answer to this question?
Actually, I think we're talking about...
Okay, the discussion starts. Go ahead.
Okay,
I think we're on the same page.
Yeah. So I think we are on the same page with your question, Dr. Forges. The idea is that we should not be always just listening to the data-driven approach. We should be balancing it with the intuitive. So that's the main idea behind this, is exactly what you mentioned, because we are afraid that at one time we're gonna reach to be all of us like Spock, and we're gonna lose the Kirk approach. You see, this that's the danger, and that's why we're here suggesting a balanced approach. Means like Kirk used to do. He used to listen to Spock. Spock, tell me what is the situation, and Spock will give him what is the situation, but the final decision is for Kirk. And this is what we are kind of suggesting in the study, is that we should combine the data-driven approach through AI and through any data acquisition mechanisms with the human approach of intuitive understanding of what's happening, empathy, compassion, etc. And I'm also a big fan of both. So Erik, also may the force be with you. I'm also a fan of Star Wars. I'm a fan of both. I'm not out of...
Okay, there is another question by Dominique. Do you have a mic?
So I'm going to start with a little story, and then I'll ask my question. And so I don't know how much of an Oilers fan you are, given where you reside and what is going to be happening tonight. But Saturday, you know, I use all of my data analytics and my understanding of hockey, and I was convinced that the Oilers would be eliminated in 4 games, to the point where we invited friend over and didn't even watch the game. So I turned the TV on, there's 3 minutes left of the third period, and then I just realized that I have probably missed the most beautiful hockey game that could have been played. Or that was played this season. They won 8-1 for those who are not following hockey. And now the cup is coming to Edmonton, right? I have renewed enthusiasm. I believe it's going to happen, and the team also believe that. I think they believe that they could maybe. There's a glimmer of hope, right? So my question is, what is the danger of characterizing you know, people's or way of thinking in one way or the other, when in reality people can change? I'm not going to say their personalities, but definitely their outcome and their energy and the way that they interact with the world based on the context in which they're living.
Yeah, perfect. Thank you so much for your question. And I think the answer of your question is already in your question itself. Like you mentioned Oilers, like based on data, based on like facts, we like even the most optimistic Oilers fan, like they were like would say like we're going to lose the fourth game and the cup is not like going to come to Edmonton anymore. But as you mentioned, people can change. Like they changed their mentality, but the data was same as before. This change, it will not show itself in the data and like what will happen. So that's why we're mentioning we need a balanced view. This is the captain, this is the Captain Kirk approach to come see, okay, this is not being showed in data, but I believe in this team. We have the hope. I see the potential. I see the difference. I see the change in that, and we need to continue. So you can change the what will happen in the future. If you go totally on the data, like you will say, okay, we lost 3 games, like the difference was at least 3 goals in each game, and we're going to lose the next one also. But you see this mentality, the role of the leader that it's totally ignored the data, what happened, and use the data in favor of the team to change, to like somehow fix the problems and come and change the whole situation in a way that now people, even though they're behind with 2 games, but most of the people, they think that they can do it. I think this is the whole thing that we were trying to show in this presentation, that there are so many things that they're not shown in data, and based on that, because AI is working, the food for AI is data. And there are things that they're not shown in data and can be only understood with human. I don't know if I could answer your question. Dr. Farook can help me also here if he has something to add.
Yeah, this is good. I agree with you. People can. There's a danger in characterization and in putting people in compartment. And I was going to ask if there was a bias around picking, Star Trek. There's a great researcher that I enjoy. His name is Dave Snowden. He does a lot of work on complex adaptive system.
Yes,
and he used Frozen 2 as a film analogy, right? It's Elsa doing the next great things, right? So there's a lot of things that we can do to change and shape the future. So yeah, thanks for your time.
Thank you.
Thank you very much. Okay, so we're at our next coffee break. And as we are 5 minutes late, we'll have a 10 minutes coffee break. So we'll start at 3 o'clock and 17 minutes. So I guess there is still coffee. What else? Yeah. Okay, see you in 10 minutes.
Side than lean side. I think though what I will talk about today though will apply to any type of process or technology innovation. So you can kind of take the lessons from today's presentation and apply it to process, lean construction technology, or lean technology processes as well as technology processes. So what I'm sharing with you today, I've done in collaboration with Dr. Gina Neff, who is a social scientist, and together we've studied the ways that people make change in their workplaces. The work that we studied in almost over a decade ago really looked at building information modeling and energy modeling. And more recently, we've gotten into collaborative project delivery. So our research has spanned both the process of project delivery as well as the technology. The technique we present today is called negotiating innovation. And I'm going to be able to explain to you kind of how that works. So one of the aspects of this negotiating innovation has to do with how we think about the future of work. And when we think about the future work, it comes from many places in our society. At the kind of larger industrial setting, it comes from media and popular press, our different magazines or websites. LinkedIn is full of images and articles talking about how work is changing and the future of work. We also have technology pioneers and software companies that are thinking about the future and thinking about how new technology will change the way we work. Of course, currently the technologies that are very highly cited are digital twins and artificial intelligence. But those are only the latest of kind of terms that we've talked about in revolutionizing construction and operations of our built environment. We also have a lot of industry leaders that think about the future of our industry. And you go to any number of forums, many of these ones here are in the US side where I'm from, the Seattle based in the US. And we get together and talk about the future of work in a lot of different conferences, including the one you're sitting in today, thinking about the future and the ways we can make things work. In the work that I've done with Gina Neff, we study the practice level. We go into teams and workplace environments, and we understand how those variety of future visions from conferences, from websites, come into practice and how people start thinking about and seeing their immediate work change and their workplace change, the way they work with teams. So one of the questions we've taken up in our research is how teams make sense of new technologies and negotiate these new ways of working together. So what we see is the future, making the future happens at all of these different levels throughout the industry. So to take a step back from the negotiating innovation for a minute, I want to talk about the lab that I'm in and a little bit about where we come from and where we bring this, what research has brought this theory to you. So CERC is the Center for Education, Research, and Construction, and we focus in this center on bridging between theory and practice. So bringing the ideas of scientific exploration into the industry and into practice. And my lab is called the Communication Technology and Organizational Practices Lab. Here we think about information technology and collaboration with the goal of making projects better. And making projects better are making them better in two ways, both the delivery of projects, so improving the way that we do design, construction, and ultimately operations of the built environment, but also ending up with a final product from the design and construction process that results in higher performing buildings and facilities. So that goal is multifaceted, both improving the process and the product of design and construction. So we've done this in many different types of projects. I've been at this for a while now. So our original work was done when building information modeling and energy modeling in the 2007 to 2016. And there we really found that the organization of teams need to mirror the technologies that they're working with. Under global distributed teams and virtual reality, we studied from, again, the same time frame, 2007, but really all the way through 2022. We were ready for the pandemic lockdown when it hit, having worked in global teams for a while. What we see in these spaces is the need for multiple types of media for collaboration, effective collaboration through technology. We've also had a stream of research looking at a more technical aspect, and that is information exchange. But as we look at the ways we structure data and exchange data across different systems, we find that human in the system is still a very important element of any technology system, that we are not going to be handing off our work to automated systems like AI and robots, but we still need humans to make the technology work. And finally, more recently, we've gotten into smart buildings and digital twins, and looking at specific issues related to cybersecurity, IoT, and changes to work. So I've been thinking about technology and process for a long time in several different contexts. So our story begins in 2007 with building information modeling. We use a research method called ethnography. So the title of this series is called BIM and Lean with the social scientists. So ethnography is a social science methodology where we go in as observers and watch teams work and develop our theory. My lab specializes in using grounded theory. So we look at what is happening in the field site and develop theory based on our observations. And in this ethnography, what we see at that time is BIM being introduced to the MEP, the mechanical, electrical, and plumbing coordination teams. So we triangulated our findings from the ethnography with national interviews across the US in 5 of our major metropolitan areas. So we had over 65 interviews across the design and construction fields, architecture, engineering, and builders. And those interviews lasted from 60 to 90 minutes. And we were talking about BIM and collaboration and high performance buildings. So we were thinking about their experiences, their cultures, the ways they're communicating, and how these technologies were changing the ways they were doing design and construction. And then we had 2 field sites, Hill Hospital and Downtown High Rise. And those were field observations. We spent 7 to 12 months observing these teams. And we had additional ethnographic interviews and collected materials from the teams. We were so successful in that project that we ended up doing a follow-on longer longitudinal study of Lakeside Lab for 3 years. And we continued to do interviews, national interviews, mostly based on the West Coast where we're based, with architects, builders, and engineers, thinking about green building, collaboration, and BIM, with an additional 18 interviews from our longitudinal study. So what were we looking at? This was the practices that our teams were moving away from. In fact, when we walked into the first meeting of Hill, it looked more like the picture here on the left. They had a shared table. They had pushed tables together. They had their super plot laid out. They were all hovering around it, drawing on top of it with markers and making annotations to each other, and then finally signing off at the end of the day that they've all agreed on how they're coordinating their systems. So they quickly moved from that logistics to this one, where they had a shared screen on a smart board, and they were looking at a consolidated or federated model together, and working with that. And we were also seeing at the time, while Hill Hospital didn't have this, but other interviews that we did, we were seeing also the field kiosks, sometimes called BIM kiosks, where they would take the models out into the field. So the field's foremen and workers would have access to the models right there. The BIM kiosks, I think, have now moved more towards iPads. You'll see project engineers, project managers were walking around with iPads in their back pockets, and they'll pull them out for their documents and models. So the new workflows we were observing were called federated models, where the models were made from different subcontractors in the project. And so we were observing a lot of these new workflows. They needed to share have shared servers where they were sharing files. They needed to think about their file naming conventions. They needed to think about what colors they were going to pick for their different systems and the system organization. They were working on clash management. They were thinking about their MEP schedules and how those coordinated with the broader schedule. And they needed to revise the way they were running their coordination meetings. They were no longer looking together on a super plot, but now had to navigate around this three-dimensional model. So what's happening about this time in the broader industry level futuring, as I opened our talk today, I talked about the ways we were seeing futuring in lots of different levels. In this higher level, the software developers were coining the term building information modeling and defining kind of the stakes of the game, the stakes of what they thought this technology was going to be about and how it was going to bring about a paradigm shift in the industry. So they put forward this idea of digital databases. BIM are now digital databases, and that's going to transform the way that we create and exchange information throughout the project process. They promised that this was going to be a much better tool for managing change and really tackling the waste in information reuse. So in lean construction, we often talk about waste. So BIM was introduced as a waste reduction technology where we can reduce the information recreation at every transition point. Because if we have a database, we, in theory, could exchange the data from one software to the next one down the supply chain. So you take a structural model, you're able to import it directly into the digital tools that actually make the steel. And that direct digital exchange reduces the waste in recreating the design in the fabrication tool set. And one of the key aspects at this time and starting in 2003 and really kind of living throughout that decade was this idea of a central model and the paradigm shift to a central model or a central database where all information was held. But we now know today, with retrospective 20 years, that a central model was perhaps an interesting paradigm shift. It's still in the industry today to kind of think about how to centralize our information, but organizationally we're distributed and we need to think about federation. And so the central model idea, while still exists, it was part of the great debate then and continues to be a tension that we work through when we think about centralizing information. So here's part of the debate. Bentley's response to Autodesk's white paper that defined building information modeling with a central model concept was, we believe that starting over with a new incompatible platform, as Autodesk suggests with Revit, in order to achieve these goals is dangerous, wrong, and wholly unnecessary. So they battled it out. There were an in-person debate at Georgia Tech and a number of white papers created and different articles at the time. But one of the main debates was centralized versus federated databases. And that really structured the way that thinking came into our team. And they were struggling, okay, so we need to somehow centralize our information, but they ended up federating their information because they recognized that we have these different types of models coming from the trades, and a federated model was the way that they managed to create a central repository. The central repository became a repository of many models. So when we look, then that was the first generation, that initial team. This Lakeside Lab, I kind of think of this group as a second generation adoption. They were closer to starting in about 2010, and they were, each of the detailers here had experience in federating BIM models together and working through this new collaboration process. But when they still started with drawings. In the first meetings we watched them do, they were bringing in drawing sets. They had underground utility drawings, which is kind of illustrated there with the cloud on it. And they were working through this problem. Wait, let's get structural drawing in here so we could see this shaft. That's a problem. No one can see the shaft. So they bring the structural drawing out and lay it on top. when they're obfuscating some things on the bottom, right? And then one of the mechanical detailers leans over to me and he says, you see how one thing affects another? And then the mechanical manager says, when we get more organized in Navis, we'll have a list. This is only 50% of what goes in here. So they were recognizing that they were challenged by this drawing technology and knew that Navisworks, the tool that was going to federate their models, would really help them see together. So one of the big benefits that we see from the introduction of 3D models and federated models is being able to see together and understand the spaces together, helping everyone understand the end and perhaps even shared discovery around what the shared problems are. Here we are, so seeing together, but seeing together was more than truly seeing the models together. It created a shared process of generating views. So they had to work together to see together. There were also this idea of reserving space in the model. So they began to have this understanding that the model is the controlling information system that then drove the field installation. So if it was in the model, it got reserved in the field. And if the field deviated from the model, then it was the responsible party who deviated. The person who deviated was responsible for making that correction if it caused a problem. So they figured out to fit systems together in these, and they continue to do this, people who use BIM for this work, and they continue to have conversations around constructability and operations. But here they had to negotiate all of this new way of working and this new paradigm of the ways that they're working. So one of the things that we saw was in Hill and Downtown, those early teams were constrained by the siloed practices that they had inherited from previous projects. So they were they had separate contracts between design and construction. They were known as CM at risk contracts here in the Seattle area. And the owners, that would mean with these separate contracts, you would get formal RFIs coming up from construction and submittals coming from construction, and then the architects and engineers have to respond to those submittals. So there was this exchange of documents back and forth, and they ended up in formal information exchanges. Whereas in our Lakeside Lab story, that was a different delivery method with still separate contracts, but the owner had paid for the architect and engineer to be in the meetings with the MEP team. So they were able to negotiate around, they had formal channels, yes, formal channels for one or 2 weeks. But one day they all come to their MEP meeting and the subcontractor, so it was several steps away from the owner, the general subcontractor, said, I emailed you a PDF, literally leaned down the table all the way to the engineer and said, I've emailed you a bootleg PDF, bootleg being something that is illegal. And you can get a head start on the review. So the engineer and the subcontractor were able to informally connect and start the review while literally the formal document was being handed across the formal channel. The next week, they come back and the subcontractor says, the engineer asks the engineer, will it work? And the engineer says, yeah, that'll work. The submittal is in process. So before the formal paperwork got back, that subcontractor was able to buy that equipment. So what we saw in Lakeside Lab was the development of a culture of collaboration, that they not only negotiated their technology work together, but they also negotiated some new, more effective work processes that worked around these formal structures that they worked within. So they were negotiating, and this negotiation, this culture of collaboration played out in this example as well. So here they had this big piece of ductwork kind of right in the way of a lot of other systems that needed to be kind of moving in that space. And so the fire sprinkler detailer starts this story and says, right here at line A by the soffits, does the duct move? It's affecting every level. So many of the systems, fire sprinkler, piping, had to trapeze around and under this ductwork. And the architect says, I guess we'll need to take a look at what we have there, kind of trying to slow things down. Let's take a look at it. The HVAC detailer says, oh, if I have to move, it's going to be multiple hours of work. I've already made the model, so moving is going to take time. And then another detailer argues this floor sets the tone for the rest of the floor, so let's do it right. And the project engineer from the general contractor says, it's the right thing to do for the project. So they all talk this HVAC detailer into moving the ductwork because it sets up the precedent for future levels, and it's the right thing to do for the project. So they're negotiating and collaborating. The HVAC detailer, in this case, giving some time to the project for the betterment of the project and for the betterment of the other people there. So if we compare these two projects, or these three projects, the kind of first generation, what we see happening is they're mapping new technologies onto existing practices. Their existing practice of shop drawings converted into shop drawings as 3D models. They converted their super plots into federated models. They have an in-person coordination meetings to detect negotiated clashes. And they do that same thing. Clashes are automated, but they still meet, and those clashes need to be curated and negotiated in order to understand and make meaning of them and make decisions. And the team organization, the MEP, was still isolated with only formal interaction with the designers around RFIs, submittals. So they had challenges in getting their models and data from others to coordinate and use. They would use pictures of clashes in their RFIs, but they weren't finding a way to sit down with the design team and collaborate in more a siloed setting. So what we saw in the Lakeside Lab project was a much bigger transformation where they picked up where those first generation projects left off and said, we can do even better. We can find more efficiencies. One of the Lakeside Lab detailers, when arguing for working online through a WebEx platform, was the drive to the job site can take up half the day. Another detailer said, I don't even need to go to the job site. I don't need to see it. I really don't, as long as everything is accurate on the drawing. I don't have to go out to the job. Now, we can have a whole conversation around that quote, because there are benefits to going to the job that the superintendents will say, hey, I want my detailers out here. But so there was a debate on this team as to should the detailers be coming to the site or not. But all that to say, they did end up using WebEx. The MEP coordination ended up being online for most of the project, and they were able to then dial in lots of different team members when they needed to connect. And the designers were paid to be in the room for the MEP coordination. So they were there and available for that informal collaboration as well as the formal collaboration. So what we were finding is that they are arguing for that the architects and engineers like the 2D better because they could see the issues, but the tools provided more flexibility. With the WebEx meetings, people could bring other team members into discussion quickly. I'm sorry, they liked the consolidated views better than the 2D. Sorry, I misread that. I was like, that doesn't make sense. So yes, they're seeing together and they're able to convene together, right? So seeing together and convening together were the two things that they found were most beneficial using building information modeling. So when I introduced BIM and energy modeling earlier, I said the organization should mirror the technology. What we found was that though systems that were represented in the BIM needed to also be represented by the team. And we found that as well with the energy modeling, that bringing the energy modeling to get, looking at the framing of the energy modeler, the experts who were represented by the model, including the owner operators, the energy modeling was more effective when you have the owner operators and the designers gathered together around the model. So I want to be cognizant of time. You wanted me to spend this. We have lots of rich information, as you can see, but what we see in the second generation was really a transformative practice where Lakeside Lab took the new technology and then extended into additional innovation using online meetings. So what we see with BIM technologies is there's more channels for seeing, but we didn't actually say that we eliminated 2D drawings. 2D drawings still stayed in the ecosystem. So we have more channels for seeing and more channels for working together in person and online, 2 dimensions, 3 dimensions, consolidated models. Now, if you add VR and AR into that environment, you have even more ways of seeing. So what we see is a proliferation of tool sets, not an elimination of tool sets. So the model I wanted to share with you today is called the negotiating innovation model. And this comes from that rich ethnography, that spending that time with the teams, looking and watching and thinking about how people were changing their work practices together. And what we found was the innovation, negotiating innovation has 3 aspects. You could also call it the digital transformation model. So there's 3 aspects. The first is futuring work. That's how I kicked us off today, was the ways that people think about how the work will change in the future. And then in the middle here is this hard work of reconfiguring practices, everything from figuring out your file naming conventions to thinking about, your project delivery strategies and your teaming strategies. And if you have integrated design, gosh, it gets really complicated about how you're going to create teams and meaningful constellations. And then this third topic of rewriting institutions connects to the social theories of institutions. So those of you that know social institutions will get really excited and we can geek out on that together. For those of you who don't know institutions, it's basically the rules and the norms of social interaction. So it's both the formal laws, formal contracts that we work with, as well as the informal expectations. When you walked in the room today, you thought, oh, okay, I should sit around these tables. That's the social convention. It would be strange if somebody actually sat on a table or stood up on the table, right? That would be odd. And so there's social norms that we take for granted as we walk into rooms and interact with teams. So all of those layers of both the formal legal interactions and the informal social norms all influence the way people come together and work together. So what we find is when we're introducing new technologies, particularly ones that deal across teams, across company lines, and think about new ways of exchanging information, we need to rewrite our institutions, think about maybe contracting, right? Rewriting contracts, maybe rewriting insurance. And reconfiguring our practices and doing our futuring work. So let's step through this. And I promise I'll wrap up here in the next few minutes. So futuring work, as I promised at the beginning, it happens at all these levels. We have the industry levels of software and associations. We have the company levels of thought leadership and management, and we have the team levels, technology champions and practitioners. Reconfiguring practices, it definitely has a process where there's a discovery, kind of trial and error, what's working, what's not working. We all experienced that in rapid fire of COVID lockdown and figured out things that didn't work and things that work better. But teams that are introducing new technologies or new practices, like some of the lean practices you're learning about, those are also a trial and error of discovery of like, the A3 is really working for me today or not. And then there's the struggle of getting it to work. So particularly with technology, there's the turning it on problem of like getting it on and getting it working so that you can leverage the benefits of it. There are a lot, I think I think VR and AR get stuck in that getting it to work space. And getting alignment around new practices. So to do these federated models, everyone on the team had to participate equally and getting everyone aligned with how and what ways they're going to participate. And then the last step, reconfiguring the practices around constraints. There's a lot of constraints to the work. You have to communicate with your design team. If you're a builder, as a design team, you have to communicate and influence your owner. So there's all these different kinds of constraints to the work you're doing. Your fees not being the least of those constraints. You're also limited by what the technology can actually do. The futuring work says, oh, we're going to change the paradigm to centralized model. And then you get to the technology, you're like, not everybody can play in the same model sandbox. This won't work for us today. And then what the teams can do. So all of those things are part of reconfiguring practices. And finally, rewriting the institutions. So in the US system, we have the Spearman Doctrine that really shapes a lot of the laws here. So you have laws and regulations, as well as contracts and insurance. At the project level, you have the way we organize teams and the ways that we use documents for documentation. And that at the team and individual level, there's standards of practice and team routines that may or may not need to be negotiated and changed. So if you wanted to use negotiated innovation, thinking about either information technology or different types of process change, these would be some of the questions you could ask yourself. So in futuring work, what problems do we want to solve here? What's the vision for how we want to implement it? And I would posit that it's very okay to be way outside the norm, way outside what you think you could do. Right? It's okay to dream big. Central model. That paradigm has been so important. And while we haven't achieved central model, we've really, really dug into it and thought about it. And why would we want it? Why can't we have it? And that's really helped us move the industry forward. Reconfiguring practices, how will we do it? How do we change it? And what practices do we need to change? You know, what's conflicting with our future vision? What do we need to change? Maybe don't fix what's not broken, or adapt it to the new process. And then rewriting institutions. That takes a longer time. Certainly laws and contracts will take a longer time to make a shift. So what we're seeing, you know, here 10 years, 2 decades later, after BIM was introduced to the market, we're still talking about revising our contracts and changing our systems to accommodate for more fluid information exchange across our projects. So with that, I will wrap up and I open the floor for questions.
Thank you. Hey, questions, everybody. Thank you very much, Carrie, for a very different perspective on our innovation work here. We had some interesting questions which kind of gravitate around these questions that you're asking. What do you think about AI as innovation? Is it going to be something similar to what we lived through with BIM, or we're still living through?
Yeah. I think so.
Another level, sorry.
Oh, that's okay. Go ahead.
Yeah, I was saying, or is it going to be at another level of disruption, and I don't know what do you think will be the effect?
Well, given this research, we think that it will have a similar journey where there'll be a lot of experimentation, but the institutional norms of practice will pretty much hold the industry in place. So while we aspire to kind of transform our industry in kind of a shockwave style, that's not the way this type of industry can change, because it's so complex with the network of companies that to change, you have to coordinate that change across multiple companies and multiple projects. So I think that we are in a way confined by our institutions, and change happens slowly and pragmatically because of that structure. All that to say, my thoughts on AI right now, and Gina and I think a lot about this because Gina is currently director of the Mindaloo Center at Cambridge, and they're focusing on AI and the impact of AI on society at large. So I'd love to have her here for us to discuss this question together. My thinking about AI in construction right now is that we won't be using the larger AI models that are so kind of in the media right now, the chat GPTs of the world, but we're going to be using much more tailored AI models that are, you create an AI box, if you will, and you put the documents that you want in that box. And then you can ask the AI questions about the things in the box. And that way you have a curated set of information that the AI is giving you information back on. I think that's the type of AI that design and construction will really be able to leverage, and may automate some things that are tedious for us to do right now, counting all the doors, counting all the windows. You could kind of have your AI box, put your design documents in it, and start asking questions of it. So that's the kind of AI that I can see will be more kind of useful, both, and I think in almost any business setting, because part of the challenge with the larger AI is the misinformation and they call it hallucinations, that it's makes stuff up and you can't rely upon where the sources are. So to kind of avoid that, you kind of create your specialized AI tool sets. So that's my prediction today. We'll see in 6 months if that's still the case.
Okay, it is recorded. Okay, thank you.
Yeah, I prove it wrong, but I think that's where we're at.
Yeah, I was going to ask, are there some specific, in your opinion, any specific social norms that are, I don't know if I want to use the term unique to construction, or more prevalent in the world of design and construction, that prevents us from being able to innovate at a faster rate?
Yeah, we see more being less about the social norms, because we often blame our people for the lack of innovation, I think, in construction. And based on the research that we've done, we find it more the legal norms that are structuring the way that we interact. So our need to document things between design and construction, and I'm sorry, I don't know the Canadian system as well as I know the US system, but I think that you're kind of similar in terms of the design driving the construction, in terms of the risk management between design and construction. So the way we document things requires people to be very careful about what you say and what you do not say, and how you collaborate across the firms, and particularly that interface between design decision-making and construction decision-making. So that shapes a lot of the culture of our industry. And so while there's a social norm that is the result of that structure, the origin of that social norm is actually the legal structure of the industry. So yes, we could be more collaborative, right? We could be we have a thing, so I'm from a Department of Construction Management, and sometimes our students will come from families of construction their uncles or husbands, or not husbands, the uncles or fathers or mothers will be in construction. And so they'll come with a preconceived bias against the designers. But I'm in a college where we have architects and landscape architects together. And so we put them in classes together. And so they're already kind of sharp elbowing each other, of like the designers, the contractors. They're already kind of have this culture of animosity. But that culture, I think, is based more in the documentation, because as you see, when you pivot to IPD or other collaborative delivery methods, such as progressive design build is gaining a lot of momentum in the US, that you see that culture, people have to work on changing that culture and that expectation, because when you walk in the room, you kind of come with your sharp elbows, and when you realize, oh, I don't need sharp elbows here, you got to reconfigure. Teams are actually able to get there and be more collaborative in their culture of their project and the social norm of interaction. Once they know they're safe to do so, that they're not risking their company or their professional position by being more collaborative.
So to go after the sort of lean paradigm in manufacturing, we have to get rid of accountants. So what I'm gathering is that in construction, we've got to get rid of lawyers.
Yeah, that would be drastic change. But yeah, I think
Lawyers, not get rid of, but less lawyers in construction, less accountant in manufacturing.
Yeah, or we have to rewrite those institutions. I mean, I think we always need the lawyers to help us with our contracts, but we need to rewrite the contracts and the institutions around them that define the risks of how we work together. That's what IPD was really about, is to rewrite the contract so that there's shared risk and reward, putting everyone in the same pool. So
Some of my best friends are lawyers, and the case that they hate the most are construction cases. They can't stand them. So,
yeah, let's get rid of them, right? That would be great. That would be great. So
Okay, questions from the online people?
I have my chat open too. If you want to chat, if you want to put it in chat, I can read it from there.
I have I don't know if it's a question or a comment. I'm just expressing my thoughts, but to learn to change the way we work takes a lot of time, and I think that technology evolves sometimes quicker than how we can adapt from. And one of the problems that we often see here, and we're talking just before your presentation, we were talking at this table about that. Who's the first to move? Who is going to take the first responsibility of saying, okay, we'll do it this way, because everyone is waiting. It's a waiting game. Who's going to do the change? And we're going to make the change, no problem. But we just want to make sure we're really going that way. And that's the problem, maybe in Quebec, because it's a construction world here, and especially when you're talking about innovation, it's a really small community. Maybe in the United States, it's bigger, so there's someone who's going to move quicker. But are you confronted to that, the waiting game, and people saying, okay, well, we'll just wait and see?
I'll be second.
I'm sorry, Ivanka, what did you say?
I will be the second to move, not the first.
I will be the second. Yes. Oh, that sounds very familiar to me. I haven't studied that particular decision point from company perspective, but it does sound very familiar. And that's what I was referring to when I said the coordinated change, right? That you have, if everyone's going to consolidate their models, everyone has to make the move. So these teams that we were seeing, the first teams, it felt fairly coercive of like, okay, everyone, we're going to do this and you have to do it. And there was a lot of grumbling and resistance. And then by the Lakeside Lab team, everybody wanted to do it because everybody had made the change and they were finding it that it was better to manage their on-site risks. And they were at some point in the Seattle region, subcontractors were charging more for a non-BIM project than a BIM project because BIM helped them manage the risks and fabrication in a better way. So we did see that tipping point, but it did take that first initial point of a push, the coercive push of the general saying everybody's doing it, no one left behind. So yes, there does need to be that coordination, and I do see that experience of like maybe, but then you have the occasional company who's trying to be the forerunner, the one that's okay. I'm going to do that Frank Gehry project, or I'm going to do that. Something that pushes them out of the box and puts them ahead. So you do also have there's the I'm going to wait to be second, and then there's the company strategy of I'm going to be first and forerunning and figure this out so that I'm ahead of everybody else. So I see both those strategies in the marketplace. But yeah, that coordinated innovation, I think, is in any market size because it depends. I mean, if it's internal only, go for it, right? You can innovate and you don't have to coordinate that innovation with anyone else. But a lot of the kinds of innovation we're talking about across Lean and BIM needs to be coordinated across the industry ecosystem. It's a much more complicated innovation process.
Yeah, so that's what they call systemic innovation, because it has to be spread through the system.
Yeah, I like that term.
Yeah, it is a term. It's not my invention.
Like the comment that it takes a lot of work. So the research we've done, or that we call this negotiated innovation, part of the discussion is how much work this takes, right? You take work to define the futures, you take work to reconfigure practices, you take a lot of work to rewrite institutions. So work, and work, so that when you do want to innovate, you need to give your team space to do that negotiation. They need space. Often, I think in design and construction, where we're trying to innovate, we're pushing it on teams who are actively doing the work. And so there's a lot of friction and fear of like, wait, I have a deliverable on Friday and you want me to try a new tool, right? It's just like, ooh, that's a hard sell, a hard way to do it. Whereas if we give people space and time, so I partner with a general contractor in town who's created a lab, and in their lab, they use BIM. They use BIM on their projects, and they kind of have an internal profit center in their BIM group. And then they use that profit to spend time with sometimes my interns to develop new workflows. And so they give theirself space to play with the new tools and develop new workflows, not in the heat of the production, but kind of as an innovation space. And then when they're ready, that tool's ready for prime time, they're ready to put it into production. So that's one of the techniques I've heard about a company trying to make space to do the work of reconfiguring the practices, creating the new workflows, without trying to do it at the point of production, because that's a challenging point to do it.
Very nice. More questions? Thoughts? Thank you very much, Carrie. And if you have like an occasion to come here, we'll be very happy to welcome you live. Even if there isn't a conference specifically for that, but we have a big research group and a nice lab, and yeah, you're very welcome.
Thank you. I really appreciate that.
Thanks a lot for your confidence. Thank you.
Yeah, thank you, everyone. Nice to meet you, and reach out anytime. Enjoy the rest of your workshop.
Yeah. Ok. C'était vraiment une perspective sciences sociales, même si elle est ingénieure elle-même. Ok. On va aller qui n'a pas posé de questions sur les bon. Est-ce que vous avez d'autres commentaires sur ça ou on continue? C'est comme si c'est difficile. Non, pas d'autres commentaires?
It's all about people. Limite d'apprentissage, nos limites d'acceptation, les gains que chaque compagnie joue. C'est a people business.
Ok, donc on va revenir à notre temps.
C'est pas son nom, c'est Carrie
Dossick.
Je vais à Washington, je vais aller me rendre visite.
Travaille avec Scanster, je crois.
Oui, ok.
Ok, donc vous vous souvenez qu'est-ce qu'on a dit dans le système collaboratif, dernier planificateur, celui qui est sur le terrain, mais a aussi le pouvoir de donner des travaux. Ok, donc Là, on va entrer dans le système de Glass Planner, qui c'est vraiment un système. Donc, je vais vous présenter tout le système sur ces deux axes. Ça, c'est le temps de projet. Le projet commence ici, puis ça, c'est la progression du projet. Puis ici, on a en fait des périodes de planification, des périodes dans l'échéancier qui sont de différentes durées. Ça, c'est la plus courte durée que vous allez voir. Il y a d'autres choses qui s'en viennent. Ça, c'est la plus longue durée. Et ça, c'est en fait le master schedule. Ça, c'est le plan directeur qu'on accepte au début qui est accepté par le client, qui est contractuel. Donc, habituellement, après qu'on a un projet à réaliser, ce master schedule-là, ça fait partie du contrat. Donc, on ne peut pas déplacer ces jalons-là qui sont dans le master schedule. Puis, c'est quoi les jalons? On va avoir peut-être ici, c'est les dessins de construction sont finis. Ici, où on commence à mobiliser. Ici, on sort de sol. Donc de la terre. Ici, on ferme la substructure, puis ici, on fait la livraison du projet, par exemple. Donc, vraiment des grands jalons.